All right, thank you. We will get started, and we have a jam-packed, if you haven't seen the agenda yet, program for this afternoon, so let's get rolling. Our first session at 1:15 is Technical Successes, Consistent, Repeatable Worldwide Testing. And we have a group of individuals who will be speaking. I will introduce the first of those speakers. For the introduction of this session, we have Ying-Wei Ku, Keysight Director of RAN Standards and Technology, ORAN Test and Integration Focus Group, and MVP-C Co-Chair. Please welcome Mr. Ku.
Hello, everyone. Good afternoon. It's good to speak to everyone after a good, hearty lunch. So thank you for coming back on time. So my name is Ku. As Jeremy has introduced, I work for Keysight, mainly focusing on the standards activities in ORAN Alliance 3GPP. Happy to be here to share with you the journey that we took together on consistent, repeatable testing on a global basis. So that's me. Thank you. Next. So I'd like to invite my colleagues to come on stage as well. So for this presentation, we're going to do it together. Mitsu-san.
Hello, everyone. This is Mitsu from the Rakuten Mall as a Japan Otic. Nice to meet you.
Hi, everyone. This is Bing Bing from Singapore University of Technology and Design, SUTD. So host of the Southeast Asia, the first OTIC. Yeah, let's be here.
Hi, everyone. Michele Polese from Northeastern University.
Hi, everyone. I'm Victor from IORS OTIC and Security Testing Lab.
So before we get started with the presentation, we just wanted to acknowledge help from a few NTIA colleagues, especially Julie, Lariston, Kate, and Margaret for helping us to shape out the contents for this presentation. So thank you very much. So I'm going to get started here. Okay, so a few of us decided to get together, shortly after the ORAN face-to-face meeting October last year in Arizona, that we wanted to be able to look at doing something different for the Plug Fest. So the Plug Fest are basically the biannual, so every year, 2 times, the event whereby the industry will come together and start to look at putting together solutions from the ORAN suppliers and test them for function and performance. And then, so I was speaking to some of our colleagues in this presentation here, and we said we want to be able to look at demonstrating consistent, repeatable testing by pairing up labs, basically consisting of one very matured lab, which is operated by Rakuten Mobile in Japan. And as you know, Rakuten Mobile has deployed OpenRAN commercially in Japan, so they have years of experience, and as well as issuing ORU certificates. And then with 2 world-class R&D institutes, SUTD in Singapore and Northeastern in the US, the Open 6G OTICs, and 1 test house in Taiwan, which is ORAN OTIC. So there are 4 OTICs which basically came together, and Keysight has basically supported our partners in global locations in terms of making sure that the testings are basically being conducted in a consistent, repeatable fashion across the continents. So the agenda here is quite straightforward. We're going to take you through the beginning of our journey on how we basically got together, the aspects of consistent, repeatable testing that we looked at, the learnings that we've actually gathered I'd like to share with the team here, and then in terms of the next steps on the journey ahead. The alignment of this slide is not coming across, but this slide basically speaks about the benefits of OpenRAN. So as the previous speakers has mentioned in the meeting earlier today, obviously we looked at OpenRAN, there are multiple benefits, looking at diversifying the telecom supply chain. There are as well aspects of spurring innovations, getting the ecosystem for OpenRAN suppliers to be coming across globally, to be able to provide different parts of the OpenRAN solution, and as well as fostering the agility and adaptability in the network deployments. So in the figure on the left-hand side, this is what we have from a single vendor RAN solution supplier, whereby the RAN vendor would be putting together an entire system, including the RU, DU, CUs, the BBUs, the cloud transports, and the network management system. On the right-hand side, basically, you see a network architecture diagram of the open and multi-vendor radio access network. There are 3 pieces of the areas of innovation that has made this possible for OpenRAN. One is in terms of open disaggregation. So to date, ORAN Alliance has specified 12 network functions and 18 interfaces that supports multi-vendor interoperability. And then the second area basically looks at the open cloudification. Instead of deploying the virtual and cloudified network functions on the single stack solution, you start to look at having Open RAN Alliance specified interfaces like the OCloud notification APIs and O2 interfaces that separates the software and the hardware. As such, the operators will be able to look at deploying servers, the processors, the cloud, and as well as in terms of the orchestration software from different vendors. And the last bit is basically the open intelligence that you start to look at the introduction of the RAN intelligent controller, the near real-time break, non-real-time break, and the accept and ARTS on top of them that basically makes use of AML to be able to enable network optimization for Open RAN. So we start to look at in this slide comparing traditional radio access network testing versus Open RAN testing. So in both cases, testing will always be required. However, for Open RAN, it's obviously more complex due to the multi-vendor environment setups. We look at it from 4 perspectives. One is in terms of the testing ownership. In a single vendor RAN solution, the RAN supplier basically would be responsible for putting the entire system together. So testing is still being performed on each of the components and as well as the entire system. Now, when we start to look at Open RAN, as I mentioned, up to date, ORAN Alliance has specified 12 network functions and 18 interfaces and more are getting added. We start to look at having more, obviously, parties involved, component suppliers, and changes. So within the multi-vendor Open RAN setup, all the components are subjected to changes, hardware, software configuration, and how do we deal with the challenges? So in terms of the impacts when it comes to testing integration, we're going to start to look at continuous integration, deployment delivery, and testing from a CI/CD, CT perspective in order to be able to continue to support the speed and cost of evolution as compared to single vendor radio access network. The second aspect is in terms of test specifications. A lot of the discussions this morning was really around things like, for example, apart from functional conformance, we look at performance, stability, and robustness. How do you get that, right? So within the public specifications that we get today, basically developed by ORAN Alliance, a majority of the test cases right now are basically focusing on functional and conformance. The RAN suppliers today would actually have the performance, reliability, robustness test cases. However, they are not publicly available. So one thing that we look at in terms of needing to make sure that the Open RAN testing can be conducted in a consistent, repeatable fashion is to be able to increase the coverage of the public test specifications to cover additional test cases, for example, performance test cases, among others. Third area is in terms of test labs, processes, experiences. We all know that the Tier 1 RAN suppliers have decades of experiences basically performing testing themselves in their dedicated labs with dedicated teams. When it comes to Open RAN, the testing entities increases. We have the OTICs, which are basically the Open Testing Integration Centers, which are approved by ORAN Alliance. There are 19 approved to date. There are system integrators. There are more suppliers involved. And each one of them basically would have different learning curves, right, involved when it comes to testing integration. And the last bit is in terms of certification and badging. From a security standpoint, the single vendor radio access network suppliers basically do bring their G Node Bs and their E Node Bs to be certified for security by GSMA NISAS. In the case of Open RAN, there's going to be increased need for certification from a conformance, interoperability, and end-to-end standpoint, including security right now, which is going to be enhanced given the multi-vendor nature aspects of Open RAN. So why is consistent and repeatable testing important? In terms of, as I mentioned, the speed and cost of evolution and time to market, to be able to meet the operator's requirements, both from today, the telcos industry, and the private networks, the performance and the innovation and differentiation which are required. We look at a few areas of tests which are required. One is in terms of, as I mentioned, testing using open test specifications. So ORAN Alliance today published test specifications for conformance, interoperability, end-to-end. Conformance is like testing basically the bolts and nuts as individual components to be compliant with certain specifications. Then interoperability, basically you start to put together two components, and end-to-end basically is like putting a car together. So all parts of the vehicle will need to be tested. But when it comes to performance testing, we really got to look at the operator vertical deployment blueprints, because there's not going to be a single component for ORAN that's going to be designed and optimized for all kind of use cases. So this is where the work which has been done by ATIS in the US for Open RAN, minimum viable profile, which is work in progress, and there's going to be an update right after our keynote here, which is going to be the fundamental cornerstone for performance testing. And the third area is a new area in terms of consistent repeatable testing for AML model lifecycle management. How do we ensure that the models can be trained, tested, and evaluated with the correct data sets and throughout the entire lifecycle of AML models? So why is it difficult to achieve consistent repeatable testing? We've been asking this question ourselves before we started off with the Plugfest demonstration that we did earlier this year. It's the Spring Plugfest. And we decided to do something different instead of testing and then after that say this is declared success and everything's good. We started to have all the labs starting to compare the results. So we did some pair testing that my colleagues is going to share with you after my presentation here. So in terms of test labs, the calibration and the differences in terms of software, hardware, and configuration is going to be important. We have cases whereby the test results came out to be different, even though all the labs are using the Keysight test solutions and supported by our Keysight personnel in the labs. They're having different generations of the hardware, different processors within the hardware, different cables, the length of the cables connecting the equipments together that basically sets off triggers and stuff like that. They do matter. So one of the learnings that we've actually got is that in order to be able to make sure that we get the correct results every single time, the lab setup will have to be calibrated depending on the testing that you're performing. The skill sets and learning curve with the emerging labs are important as well. As I mentioned earlier on, we have partnered two very experienced test labs together with two emerging labs, and they've actually gotten to learn from each other. And then from a test processes and procedure standpoint, today there's a clear lack of documentation in terms of what are the test methodologies, how do you proceed, like for example, the meta procedures when it comes to testing, what do you need to check and stuff like that. All these experiences are basically within a few entities, they are not widespread. So we spread them during this Spring Plugfest when we basically tested together. And the testing exercise that we've actually done was a one-off effort. Basically, all the labs are self-funded. So the other challenge that we face as well is in terms of because we know that the ORAN specs are going to continue to evolve, there's going to be 6U work involved and all those things, and the ORAN solutions are going to continue to mature and be more capable. How do we make sure that the testing we've actually done for consistent repeatable testing can be actually worked on a continuous basis? And the last part of it is in terms of test specifications. Today, I would say that there's insufficient deployment readiness tests which are available in the public domain today. So what we meant by deployment readiness tests are things like, for example, the performance, stability, robustness, and the operation and maintenance tests. So these are some of the real challenges that we encountered when we basically got together on this testing exercise. Now, my last slide here is basically a few suggestions. It's basically for the governments and the funding bodies to consider for the policymakers. From a test lab perspective, helping the emerging labs to fund hands-on training, symposiums, and pairing the labs, that's just like what we did here for the Spring Plugfest, is actually really important because we all get to learn, we get to bring up the emerging labs. To be able to help fund effort for continuous testing, as I mentioned, across multiple labs is one of the invaluable exercises we've actually done, and obviously the learnings we're going to be sharing with yourself and the ORAN Alliance and other public standards bodies. To be able to increase the test coverage for public available test specifications that includes the deployment readiness testing would be key, and the development of calibration methods and procedures that can be publicly available so that all the labs will be able to get on common standing when it comes to consistent repeatable testing. And lastly, from the operator deployment blueprint perspective, we feel that the MVP effort that's been started by ATIS is a good effort. Now, maybe the suggestion is for maybe more regions to come up with their own MVPs and to be able to look at funding testing to make sure that MVPs are validated and continuously enhanced throughout the procedure. So with that, I can maybe hand over the mic to my colleague, Mitsu-san. Can I speak this? Do you want to get the on stage?
Nice to meet you again. This is Mitsu from the Rakuten Mobile as a Japan OTIC. As we may know, Open RAM supports multi-vendor RAM system, and especially ORU and ODU already commercialized as the multi-vendor the structure. So Open Front Hall integration is very important to promote Open RAM. That's why we prioritize the front-haul integration for now. Actually, for OTIC from the US and Taiwan and Singapore and the Japan cooperate globally and to achieve, to overcome this integration, the technical challenge. We would like to introduce the three topics. One is the ORU, front-haul testing, and ODU, and the ORU energy saving. First, ORU, front-haul repeatability testing, we collaborate with the Singapore OTIC. So, as we may know, Rakuten Mobile already commercialized the open RAN system, but initially we took the 4 months or more to complete the ORU integration. This is not good for a commercialization point of view. That's why we try to improve the test efficiency. To improve the test efficiency, we apply for a test automation system with the test vendor. And finally, to achieve the significant the test time reduction from 4 months to 4 days. To prove the consistent test, we deliver our NEC Japan OTIC ORU to Singapore OTIC to compare the both test results, the Japan OTIC, the Singapore OTIC, and we also quickly share our knowledge with the Singapore OTIC at the face-to-face meeting. So finally, SUTD quickly achieve the ORU repeatable testing. Hand over to Bingbing.
Thank you, Ku and Ms. Susan. Yeah, so this is Bingbing from SUTD, Singapore University of Technology and Design. Yes, so yeah, indeed, as Ms. Susan shared, we have done a very good collaboration between Japan OTIC and the Singapore OTIC in conducting this consistent and repeatable testing of ORU, focusing on the front-haul interface. And this won't be possible without a lot of knowledge sharing, and actually we visited each other's lab, and you can see from the photo we are very happy. I mean, having dinner, lunch together, and doing all these tests, laying down the cable together, and also it's not actually as simple as we originally thought. Originally we were thinking, yeah, we just repeat the same test in 2 labs. It should be quite straightforward, but it's actually not as straightforward as we think. Especially when we set our target to really do this in a very efficient manner within like less than 4 days. And we have a few learnings, because of time, just share some of the key highlights. First, it's really important to gather the information from the device vendor, from the ORU. Although the ORAN specification already detail a lot of information, but there are a lot of other parameters that we really need to nail down in details. This is a list of the parameters we have compiled together. It's actually more than 400 we need to know from the ORU vendor in order to do that, including some very critical one, for example, that needed to design whether some conditional mandatory test is needed or not. So we have compiled this list, and I will share this with our community as a best practice recommendation. Another key learning from this joint effort is that we really need to make sure the testing environment need to be specified in as great detail as possible, and we need to calibrate our testing environment to achieve consistent results. Just give a simple example. We have, for example, shared the notes about what are the hardware, software versions. I mean, what are the power connector type we're using? What are even the length of the cable need to be carefully specified, because that actually will affect some of the important synchronization related tests. This affect dozens of nanoseconds of difference will make a difference between whether you pass or fail a test. Yeah, so this is a quick overview of our collaboration with Japan OTIC in ORU front-haul testing. In addition to that, we also have the honor to work with Northeastern University, the Open 6G OTIC, and we focus on the ODU front-haul testing. Again, we work with this vendor, Synergy Tech, who is so supportive to ship the equipment to both our lab and in the Northeastern University's lab. And we have collaborated very closely together despite of our 12 hours time zone difference. And we're able to achieve consistent results, and we also look at some of the difference between our performance results, which I'll pass to Michele to share more.
Thanks, Bingbing. Hi, everyone. This is Michele Polese from Northeastern University, representing the OpenSysG OTIC. So I'll just briefly comment on some of the key learnings and results that we got out of this exercise of testing the DU. The DU is really the part where the signal processing happens in the whole 5G base station. So the starting point is that we were working in two quite different environments, located, of course, in two different countries, but also in terms of like equipment, different in terms of the specific equipment and the specific infrastructure. And you can see a couple of pictures on the left and on the right of the slide. At the center, you have the system that is being tested, which is a card that you can install on a server to accelerate the signal processing that happens in the 5G base station. And what we were testing was actually the protocol, the interface connecting that card to the radio, where the actual signal is then transmitted. And despite the differences in terms of testing setup and testing configuration, we managed to validate the same results for the conformance. So we managed to basically measure the same kind of information being sent by this interface, validating that the interface is conformant to the specification of the Oran Alliance. Then we got to do a slightly more complex test. Basically, rather than only testing the specific component and the specific interface, measuring the performance end-to-end. And we validated a couple of different options and different configurations using two different generations of hardware, two different virtualization technologies. Virtualization is what abstracts the hardware to the software. And then using two different sets of application traffic. So the application is, think, for example, your Netflix stream versus your messaging. These come with very different requirements and very different conditions that they bring inside the base station. Primarily, messaging is smaller data units, smaller packets, which are associated with a higher overhead in general, because you need to process more to receive the same amount of information. So these two different configurations led to two different interesting results in terms of the end-to-end performance, which are reported here at the bottom of the slide, showing that the configuration of the end-to-end system, not only of the interface, affects the performance of the end-to-end test. I'll now hand it off to Victor from ORE.
Thanks, Makita. This is Victor from IORS OTIC. In this year's Spring Prefect, IORS has conducted energy consumption tests on 3 different ORUs, including Action Tech, Lion, and Metanoia, using Keysight testbed. Actually, IORS is ISO 17025 accredited. We follow the standard of procedures to make sure the results are consistent and repeatable. Additionally, we assist our customers with filling the declaration of conformity. Thanks to Keysight's testbed, we can validate ORU setups rather than just relying on vendors' configurations. With these benefits, we can have a comparative analysis across different ORUs, ensuring an accurate measurement of power consumption, which leads to the key learning, the first key learning. And what about the second key learning? The table on the right summarizes the power consumption results for different antenna gains and the numbers, and also ORU being tested. The figure on the left illustrates the energy savings under different workloads for these different configurations. The blue line shows the results for changes in different antenna numbers, and while the orange line shows the results for changes in antenna gains. And what does this mean? Will configuration change affects user experience in terms of QoS? We have two photos taken from the same location and different times. From this, we can observe different time actually indicates different time traffic patterns. We can adjust the ORU configuration, such as changing the gain or the antenna numbers to fit in the current traffic pattern. And once we can make this adjustment, we can do some simple calculation to analyze the impact on the OPEX. Suppose that the total energy cost 1.2 billion. Among these, rent accounts for 50%, which would be 0.6 billion. Intuitively, if we can perfectly adapt rent to user demands, we can save up to from 360 million to 960 million US dollars. We aim at further extending the testing capabilities to ODU, OCU, or RAN intelligent controller, which will be RIG. And also, from the lesson learned from the ORU, we will ensure providing consistent and repeatable testing against ODU, OCU, and RIG. And this will also ensure that when these network functions are deployed in the field, they will meet expectation of its stakeholders. Now I will hand the mic to the Makita. Thanks.
So just to conclude and recap in these last 3 minutes that we have, this is the slides that recaps what has been done and what basically will happen and needs to be done in the coming months. We started from standards and forums, so the ORAN test specifications, events organized by the ORAN Alliance, such as the ORAN Plugfest, for which we propose the theme of consistent and repeatable testing, and our participations in different, and the establishment also of different consortia, for example, ORCID and Accord that were mentioned this morning. And we got to the green box, which is what has been completed during the Spring Plugfest, which is really a short amount of time. It's a 2 months effort where we did conformance testing of different devices, energy testing, and we worked across different labs from ORAI to Northeastern to the Japan OTIC at Rakuten Mobile and the Asia and Pacific OTIC at SUTD. In terms of what's coming, there needs to be more conformance and interoperability exercises, but also specification, especially on these new components that are part of the Open RAN architecture, but are less explored and traditional from a commercial point of view. So the RAN intelligent controller, or RIC, is a component that definitely needs further testing. Energy, as Victor was mentioning, is an important element to measure, as well as supporting emerging labs. There's actually a breakout session tomorrow on how we can train emerging labs to perform and conduct testing. And then additional testing areas, so testing end-to-end, so the MVP profiles, testing performance, testing security, and testing the AI and ML components that are now becoming part of these radio access networks. So just to touch on this RAN intelligent controller testing for AI use cases, the RIC is the component that truly brings the intelligence in the ORAN ecosystem, and testing and achieving a consistent and repeatable testing for artificial intelligence enabled application is a key challenge. So the different labs that have been part of this effort and additional labs are, as well as the ORAN Alliance, are working to define test specification and to define test procedures for AI and ML applied to ORAN. With this, I would like to thank you all for the attention. I would like to thank the other speakers, Ku, Victor, Mitsu-san, and Binbin, and we'll be around if you have questions. I believe the MC is coming.
We just ran out of caffeinated coffee. All right, we are striving to get back on track. So let's hit the next session very quickly. And we have the minimum viable profile update. Ojas Choksi, the principal technologist from Addis. Welcome.
Hello. I'd like to thank NTI for giving Addis an opportunity to provide an update on its MVP initiative that we had announced in February of this year. I'm very pleased to announce that the first version of the MVP has been published and is available for download via the Addis website. In today's presentation, I'm going to go over the motivation for the MVP initiative. I'm going to go over the potential uses by various stakeholders and provide a very high-level overview of the kind of requirements that have been captured in this version of the MVP. Given the concentration of the 5G RAN equipment market, NTI has been a very strong proponent of leveraging Open RAN to diversify the trusted supply chain. Over the last few years, significant progress has been made in specifying and developing Open RAN standards. It still has a lot of optionality, though, incorporated into those standards. It's the nature of all standards. As NTI was starting deliberations with various stakeholders, there was a quick realization that there is a gap in that the new entrants, the new suppliers, need to have visibility into what the MNO needs are, what their requirements are. This MVP is trying to fulfill that gap. So this MVP aims to stimulate the Open RAN market. It aims to stimulate supplier diversity by identifying a set of requirements that the MNOs need and require as part of their deployment to give better visibility to new suppliers. It aims to facilitate interoperability by listing requirements or specifications that are listed as optional but are required by the MNOs to facilitate interoperability in a multi-vendor environment. It aims to accelerate the development and deployment of carrier-grade Open RAN systems by providing greater visibility in terms of what the performance requirements are for MNOs to really consider Open RAN products for deployment in their commercial network. And finally, it also provides an impetus for innovation by stimulating supplier diversity, facilitating interoperability, as well as defining an extensible baseline architecture as part of the MVP. So the main goal of this MVP was to establish a set of requirements which are common across all North American operators to provide better visibility for the trusted supply chain. It tried to identify many of the requirements or many of the things that are listed as optional in the specifications which were required by the MNOs as part of their commercial deployment. At the very start of the initiative, the decision was made to not create new specifications and fragment the ecosystem, right? The intent over here was to develop requirements based on existing specifications, which in this case would be the ORAN specifications and the 3GPP specifications. This led to defining a set of requirements which are architecture related, a set of requirements which are functional, feature related. It led to definition of requirements which are performance related that the MNO needs. And finally, it led to the definition or it is leading to the definition of interface requirements and identifying a subset of the IoT profiles that have been specified in the ORAN specifications. This version of the MVP includes the first 3 sets of requirements. The work is continuing within the working group to identify and develop the interface requirements and those subset of IoT profiles. We are hoping that the work will wrap up at the end of this year, and we will be able to incorporate those requirements as part of a subsequent release of the MVP later this year. So before we go into the potential use of the MVP and the high-level overview of the content, I wanted to provide a brief overview of the timeline for the MVP initiative, right? So as I alluded previously, there was a realization through deliberations between NTIA, system vendors, and MNOs that what was missing was the MNO needs. So in early 2024, in documenting MNO requirements and needs. So in early 2024, MNO members of ATIS put forth a proposal to the ATIS board to lead the MVP initiative. There are several reasons for selecting ATIS. ATIS has a very broad and diverse membership spanning both MNOs and system vendors. ATIS has been a trustworthy partner in leading strategic industry initiatives such as the Next Gen Alliance work, aka the 6G initiative for North America. Additionally, ATIS is very familiar with 3GPP standards, being an organizational partner of 3GPP. And finally, ATIS already had an established MOU with ORAN Alliance. It's much easier to work through the capturing of those requirements that the MNO need as part of their Open RAN deployment. So once after the approval, the ATIS leadership worked with ATIS, with NTIA and MNOs to establish the goals and the scope of the initiative. Invitations were sent out for participation. The initiative was launched on March 7th of this year. The working group for the past 7 months since March, the working group has been working diligently, meeting every week to identify and reach consensus on the requirements that should go into this document and what should be kept out of this document. It's always, when you have so many participants, it's always a difficult process to reach consensus in terms of what should be included and what should be excluded. So in terms of participation, there was a wide array of participants spanning MNOs, system vendors, RAN hardware vendors, RAN software vendors, cloud infrastructure vendors. We also had government entities, government agencies also participating as part of this working group. It was a true public-private initiative, so to speak. Again, the invitation, the participation was by invitation. Given the aggressive schedule that was laid out for this initiative, the thought process was that if we had a small team, work can be more effectively done within the group, and therefore it was not an open initiative. It was by invitation. Now, before I go into the actual content of the MVP, so what are the potential uses of this MVP? So on the left side, I'm showing what the inputs to the MVP was. So I think I already mentioned it is based on ORAN and 3GPP specifications, right? So there are no new specifications coming up through this MVP document. On the right side, it illustrates there are 3 potential uses of the MVP are illustrated. The first one is the RAN product vendors to develop products using the requirements laid out in the MVP, knowing that these requirements are what are required by the MNOs within North America. The second potential use is for the test labs and the equipment vendors to develop automated test suites that spans not just interface testing, but also functional and performance testing. And the third use that's kind of depicted over here or illustrated is for the MNOs to take the MVP and use it as part of their RFP procurement process, as well as for their own internal interoperability and integration testing within their own lab environment. So these are like the three illustrations. There could be other use cases by the stakeholders. We encourage everyone to review the MVP and provide us with feedback in terms of what are the potential uses it can be used for. With that, I'm just going to step into what is contained within the MVP document, this version of the MVP document. So there are 4 categories of requirements. There are the architecture requirements, there are the functional feature requirements, there are the performance requirements, and then finally, we also have a broad set of security requirements. And I'm going to step through each of those. In terms of the baseline architecture that is part of this version of the MVP, it is kind of aligned with the architecture that has been specified within ORAN Alliance. As you can see, it incorporates ORUs, ODUs, OCUs, OCloud, as well as the SMO framework. Given where we are in terms of the deployment cycle for 5G, there was a general consensus within the working group to focus on SA deployment, specifically wide area SA deployment using outdoor macro and micro cells. That's a typical deployment that MNOs are well versed with. Given the fact that 5G it supports many different use cases and verticals, we had to narrow down the scope, and the thought process was, let's start with the wide area coverage scenario as a use case, and then progress the work in future versions of the MVP. There are 2 key areas of discussion. One was around RIC, the other one was around inclusion of OCloud and SMO framework. So in terms of the RIC, there was a general consensus amongst the MNOs and all the other participants that we should, that the non-real-time RIC and the ability to introduce innovative R apps was a critical part of this baseline MVP. Where we didn't have consensus was on the near real-time RIC. So that's not part of the baseline MVP, at least this version of the MVP. And I think most operators are interested in understanding better of what use cases can be implemented, what the use cases that cannot be implemented by non-real-time RIC that require real-time RIC. They're also very actively monitoring the development of the E2 services within the ORAN working group. But at least in this version of the MVP, non-real-time RIC, the near real-time RIC is not part of the baseline architecture. In terms of OCloud and SMO, there was a general consensus that those are critical enablers for deployment of RAN functions within the multi-vendor deployment. And they are part of the baseline MVP architecture in the document. There was some concern expressed about the maturity of the O2, but the working group decided to include them with the notion that it would serve as an impetus for ORAN to progress the work on maturing the O2 interface. So both OCloud and the SMO are part of the baseline architecture. In terms of the functional and feature capabilities, they are pretty much based on, they are a subset of requirements specified in 3GPP release 16 and 17. They span from physical layer features, mobility features, carrier aggregation features, MIMO features, features related to essential services like WPCS, emergency alerts, SON, network slicing, etc. It also includes a subset of SMO and OCloud requirements. They are kind of aligned with what's been specified within the ORAN specifications. There's a broad category of performance requirements, performance metrics that has been captured. There are value ranges specified for several of these performance metrics. In addition, to help with the performance testing, test method and configurations have also been referenced. There are a broad set of requirements spanning individual functions, interfaces, as well as common requirements, guidelines, best practices. I'm running through because I'm getting the red flag over there. And finally, in terms of what's happening, we are continuing to work on identifying interface requirements and a subset of IoT profiles. We hope to complete that work by end of this year and publish that as a subsequent release to this particular version of the MVP. Final plug, you can find the MVP document at mvp.addis.org. I've just given a very broad overview of the document. I encourage everyone to download the document and review it in much more detail. Thank you, everyone.
Thank you, Ojas. And now we will transition to the fire drill of the day. The slide fire drill was a warm-up. This is the real deal. We are heading into our time for the lightning talks. So let me briefly, I'll cut my remarks down very brief to introduce lightning talks, and then I will direct folks who are going to be speaking. Okay, so first, the goal of the lightning talks is to introduce your organization, all the speakers that are going to be lining up. Introduce your organization, your areas of expertise, and tell the audience why they should collaborate with you. This is not a time, and please do not use this time to market or sell your products, services, or other abilities. The mission is to communicate these things in 3 minutes or less to get us back on track. As you can see from the agenda, we have a lot of lightning talks to get through. Raj here in the front row will help me do that. If you haven't been up here to speak yet, you'll see a yellow card, and I'm going to ask you, Raj, to do a 1 minute warning for the yellow card, because these are very short, 3 minutes. And then when you get the red card, that's pretty much it. I'm going to find a hook to pull people off the stage, just so we can keep rolling and stay on schedule and conclude the day on time. Each lightning talker has a slide that will be displayed up on the screen here. In addition to viewing them today, they are available on our website. If you go to its.doc.nti.gov on the IORS webpage, you'll find them there. So if you don't get a picture, don't worry about it. They're all publicly available. If you were not selected for a lightning talk, but would like to introduce your organization, we do have a few minutes. If you look at the agenda after our last block, the industry lightning talks, where we will have an open mic. So if for some reason we made a mistake, we did not get your slide up and have you included in the program, please stand up at that time in one of the mics in the room, and we'll allow a few folks to introduce themselves who were not otherwise on the list. A final note about the process here, since we have so many speakers, I will ask, and to start off with the federally funded labs and organizations and lightning talks, go ahead and we're gonna have you line up over here in the corner. So everyone in that group, go ahead and make your way over to the front of the stage for the federally funded labs and organizations lightning talks. We have about 10-ish. Each group, starting here, and then next it'll be academic, and next it'll be industry. We'll ask everyone to line up. We'll have someone keeping everyone in the correct order for the slides. And I will have one speaker join me on stage. We have 3 minutes, and then we'll ask you to politely leave the stage and have the next speaker come up so we can keep this rolling. Okay, are you ready to go? First up is federally funded labs and organizations lightning talks. And our first lightning talker is from ITIS's own Crane Lab. 3 minutes, Mr. Thompson. Yes, sir. Thank you. Thanks.
Okay, thanks, Jeremy. My name's Tim Thompson. I'm an electronics engineer working for NTI ITS, and I'm going to talk to you today about the Communications Research and Innovation Network, otherwise known as a Crane Lab. I wanted to let you know that Sharik Ashfag is our division chief, and Angela McCrory is our project leader. So how do I advance to the next slide? Okay, that's right. It's not here though, right? There we go. Okay. All right, so the Crane Laboratory, the approach we've taken is to start off with the traditional 5G RAN and then integrate Open RAN into that. And the lab is a major resource for research into next generation communications technology. Our initial focus is to integrate in Open RAN equipment into our Tier 1 5G network core. We've developed an Open RAN test plan based on the O-RAN Alliance specifications. That's consistent with what was done in the 5G challenge that Cable Labs conducted all the testing on. We do have close alignment with the UK Sonic Lab. We've been meeting with them periodically, and we've shared test plans as well as, what test equipment capabilities we have. We do plan to collaborate with other labs in the future. This on the right side of the screen is kind of a network diagram. We do have a non-standalone core and a standalone core from the Tier 1 network provider. We've got 3 different radios in there. One of them is an LTE radio. The other 2 are actually 5G radios. We also have a enhanced voice core, so we can do VoNR and VoLTE testing. We've already integrated one Open RAN vendor into our network. We're in the process of integrating a second one. We do have, as an extension to the network, traditional network, we have a millimeter wave radio deployed out at Table Mountain. We've been doing some active antenna characterization and out-of-band emissions testing out there. We do have a emulated 4G and 5G core, as well as we have a load tester for both 4G and 5G. And our goal is to come up with consistent and repeatable testing, and willing to work with other labs. So I think I'm good. So I'm less than 3 minutes here.
All right, thank you, Crane Lab. I'm going to keep this short and only give the titles of the organizations. Next up is DoD's Future G office.
Okay, no, it's me. Hi, everyone. My name's Ted Woodward. I'm the technical director for the Future G office within the Office of the Undersecretary of Defense for Research and Engineering. That's the principal director of that is Dr. Tom Rondo, who's also with us here today. I'm thrilled to be speaking to a global audience, because if you take nothing away from what I have to say today, you should take away that the Future G office within OUSD believes that Open RAN is a terribly important technology, and that if we're going to advance it, we're going to require a global effort to do so. So we've been active in this space for a number of years. Many of you will already be familiar with us from our sponsorship of the 5G Challenge events in 2022 and 2023, and the RIC Forum in 2024. So we've been busy in that space for a number of years. And the reason for that is that we believe that's essential to achieving our mission, which is to take advantage of commercial wireless networks as they are relevant to national security and defense. And that without addressing that, without changing the fundamental way that we build these networks, we can't be successful. So we have a number of elements in the roadmap of our technologies that we've carved up the Future G space into a number of different areas, and you can see those areas listed here. All of them have an essential element of Open RAN to them. It's very challenging to try to realize ubiquitous, secure, and instant access systems in closed, proprietary, non-interoperable systems. With open, modular, interoperable systems, it becomes possible to take things out, put new things in, and achieve innovation. I do want to take advantage of this opportunity to talk about one of the key elements of our roadmap, which is the Okudu effort. Up in the upper left-hand corner of the slide is something called the Open Centralized Unit and Distributed Unit. And the emphasis here is on open source. So to go beyond Open RAN systems to open source systems, we believe will be very disruptive and innovative to the industry to create performant, open source solutions to greatly increase innovation and openness in the industry. We heard a lot of interesting things today about the need for creating a domestic industry as a driver for Open RAN, the need to create a profitable system that operates at $5 ARPU, and all of these essential items are facilitated by having open source implementations. So if you're interested in these questions, we really encourage you to get in touch with us. There are a number of representatives of the Future G office here today. For those of you who are with the Future G office, if you could just raise your hand, wave it around, talk to the people who you see, and we'll look forward to further interaction. Thank you.
All right, thank you, Future G. Next up is the I14Y Lab in Deutsche Telekom.
Yeah, good afternoon. My name is Andreas Gladys. I'm the coordinator of I14Y, which is a publicly funded project funded by the German government, by the Ministry of Traffic and Digitization. So we are a consortium with different partners from different industries, represent 3 operators, 2 system integrators, 3 SMEs, and 2 partners from academic side. So in that sense, we are a model of the ecosystem, and we sense all the challenges of the ecosystem to bring together all the different interests. So our goal in general is to deliver test infrastructure, to make it easy for smaller companies to get access to the test infrastructure. And the main goal is for sure to achieve exchangeability of Open RAN components and to show the exchangeability and to harden the exchangeability. Moreover, we work on consolidation of requirements from the different operators or from the different partners, and we also contribute to the different organizations like ORAN Alliance or TIP. So what have we achieved in the past? As one of the OTECs, we are one OTEC and we are a TIP authorized lab. So we did run multiple ORAN plugfests. We support the plugfests. We issued this spring one ORAN certificate for conformance testing and one for end-to-end badging. And moreover, we support the TIP with 1 silver badge in the domain of PCI optimization. We support the ecosystem mainly in Europe by running so-called I14Y lab summits. Since the project started in 2021, we could celebrate the number 3 summit last week, already mentioned by some of the previous speakers. And more importantly, our offers are beyond the ORAN testing and certification. Our offerings are test as a service and development support, which is important for smaller companies who are not so familiar with all those requirements coming from the large operators. We provide lab as a service with the same orientation. And in that context, we want to develop further all those points concerning certification embedding, because our learning was that this exchangeability of components is still not a dream. We are, let's say, 60% there, but a lot of parts are still missing, and that is one of our missions in the next months and in the next year to improve that. So then we have already established global collaboration with ITRI from Taiwan, and we have collaboration with Sonic Labs already, and more to come. Hopefully we can discuss that here at this meeting, at this conference. And we also want to host and will host the next Plugfest Fall 2024 with focus on conformance testing and energy efficiency. Thank you.
Next up is Idaho National Labs.
Thank you. Hi, I'm Arup Bhuya from Idaho National Laboratories, where I'm a directorate fellow and the director of the IORS Security Institute. Next slide, please. Or do I do that? Next slide. There's only one slide. Oh, there was another slide there. But anyways, you'll see that in the package. I did see that the website there. So at INL, for 5G and Open RAN, we focus on the security to make it secure to use, especially for mission-critical communications and use in the critical infrastructure. In addition to the protocol security, we also focus on the security of the spectrum that's used. With the need for spectrum coexistence going forward, we'll need more advanced and distributed spectrum sharing technologies, and how to keep them secure at the same time is our focus as well. In the research component of the Wireless Security Institute, we take advantage of the LDRD research, lab-directed research, to start on the technologies right at the inception. A couple of examples of Open RAN research we are conducting now is one on where distributed optimization is done and then securely combined into a global optimization process, just like optimization happening in Open RAN in different segments of the Open RAN. The other one is taking advantage of the actual, the RNC intelligent controller, RIC, to support secure cellular communications for nationwide operation. We are also very fortunate to have our wireless test bed, which is located in 890 squares of federal land. And we operate our own networks, cellular and non-cellular, from 5G going all the way back to GSM and so forth, using the, there it is. So using the NTIA's experimental station status, and that spectrum flexibility, a lot of US government agencies and other customers, they find it very useful to come and have their own experiments in addition to our own. But obviously, the collaboration is the most important part. A couple of times a year, we have wireless security workshops where we sit down with our collaborators from industry and academia and government, of course, and we look at the state of wireless security, and more importantly, we identify what are the security problems that we should address at the national level. So at the end conclusion, we are very proud, very happy to be part of this international collaboration and looking forward to contributing to its success. Thank you.
All right, next we have Digital Catapult from the UK.
Thank you. Good afternoon, everyone. My name is Paul Sludden. I'm the project director for Sonic Labs with Digital Catapult in London, UK. So first of all, I'd just like to talk a little bit about Digital Catapult. Digital Catapult is a deep tech innovation organisation. And with that, we help businesses grow by applying deep tech across many different industry areas of focus. And one key focus areas for us is Open RAN, where we're accelerating technology innovation with Sonic Labs. And so Sonic Labs is a government-funded program in partnership with Ofcom. Ofcom is our government telecoms regulator. And with that program, we're supporting the government's supply chain diversification strategy. And with that, we are providing a commercially neutral environment for testing of interoperability and integration of Open RAN products. And we're accelerating the introduction of Open RAN products, starting with Open RAN. So, and that really is taking technology from early stage development all the way towards the pathway to deployment, which is a key area of focus for our government. So we're now in our third year of the programme, and so far we've tested over 50 product combinations from about 20 vendors from all around the world, assessing various E2E testing and performance scenarios according to ORAN specifications, and then we also started to add performance evaluations both in our labs and in our indoor private network that we have in our office in London, as well as our outdoor network in central London, where we have a real-world replication of an MNO implementation, which includes macro cells and small microcells. So it's really been a great journey. Things have gone well, and we've progressed, and we've learned a lot. And one of the things that has come out of that is that collaboration is absolutely key. We've signed an MOU with ITRI, and we've spoken to Julie, and spoken with Katia at I14Y, that we know that we have similar discussions with those organisations that we've been having with ITRI. We'll very quickly get into sensitive area of discussion where we really need to have detailed conversations on how to push collaboration forward. So our plans are to sign MOUs with both ITRI, NTIA and I14Y, so we can continue those collaborative discussions in a more meaningful way. So that's a very, very important aspect. You've heard it from a lot of people today, and we'll continue that discussion tomorrow. Just to give you a little bit of a flavour of what our current focus is, though, we're now evaluating Open RAN products at scale. So these are taking outdoor products, deploying them in our outdoor network. Of course, first of all, evaluating them according to ORAN specifications before we take them out to the field. Innovation is a key focus area for us, and we have a technology acceleration program where we're helping new and innovative vendors to the market develop products in our labs in a collaborative way. And so we're focusing on RIC, XApps and RApps around energy efficiency. So we're looking at two sub-themes around advanced sleep modes and optimising CUDU power utilisation in CPU cores. So we're very busy right now, and then we're also planning for our work going forward to next year. And of course, we do participate in Plugfests. So we are now entering into a third Plugfest programme and looking forward to further engagement with the industry in that area. Just one thing I'd like to finally mention is that we are, with the infrastructure that we have in our outdoor environment in central London, we're actually able to evaluate other areas. And so we're looking at what we call a Spectrum Sandbox programme, which is another government-funded programme by Ofcom, where we're looking at shared spectrum studies in the 3.8 to 4.2 gigahertz range. So a very, very full programme of work. Things are going well, and we look forward to engaging with all of you. I'm very happy to talk to anyone who would like to collaborate further on Open RAN. Thank you.
All right, quickly moving along to the Industrial Technology Research Institute, or ITRI, from Taiwan.
Oh, maybe the next slide, please. Hello, everyone. This is Maggie Zhao again. I'm the Deputy Director of ICHI. Thanks for the opportunity that we can introduce more about our 5G Open Network Lab. So ICHI is the biggest research institute in Taiwan that we drive the industrial development, create economy value through the technology R&D. So Taiwan is known for the hardware manufacturing. So we are the major supplier, so most of the ICT solutions, including the Open RAN, especially for the RU solution. So that's why ICHI established this carrier-grade end-to-end testing environment with both the SA and NSA testing environment in 2020. And this is one of the TIP committee labs, so we can conduct the TIP Beijing program. So as of now, we have the capability that we can test the solution, including the Open RAN, RIC, Open Wi-Fi, and DCSG. So as a neutral lab in the region, we work very closely with the local operators here, including the Zhonghua Telecom, Taiwan Mobile, and Far EasTone, so that we can collect the local requirement and contribute to the ecosystem. So we have regular meetings with the operator so that we can realize what are the gaps between the Open RAN solution in order to realize what can be done via our testing. And except for that, we also conduct a pre-test for Taiwan Mobile, because as of now, like Taiwan Mobile adopt the TIP Beijing program as part of their procurement process for the Open RAN solution, especially for the private network area. And this testing is extending from the Open RAN solutions to core solution. And now we even do the field testing for them. And starting from this February, we just made an announcement at the Mobile World Congress that ICHI, NTIA ITS, the Sonic Lab, and I40Y Lab, 4 of us will join together for the lab collaboration. So we do the vendor recommendation. We develop the test plan and test cases, and we even conduct the testing activity. So what we do is that we try to define the differentiation expertise from each lab, so we can consolidate the resources to make it a 1+1 better than 2 efforts. And what's next for now? That we will put some more effort to advance testing cases development and testing tool development. And we also try to contribute more on the emerging market, especially for the countries in the Southeast Asia, because we are in this region. And although we are fully supported by the Taiwan government for now, we are still thinking about some sustainable strategy, because we think it will make our business model more healthy. I look forward to the breakout session tomorrow, because we're going to discuss more about what are the topics that we can work together. And finally, that one more time, we're going to organize our 5G Summit next month on October 23rd to 25th in Taipei. So if you are interested at this one, we're going to have the forum like this one. We'll also arrange a company visits and a B2B meeting. So if you are interested, join with us, feel free to contact with me and my colleague Tiffany link over there, so we'll provide more details about this event. Thank you.
All right, next up is the Taipei Economic and Cultural Office, TECO, in Denver.
Good afternoon. My name is Bill Huang. I'm Director General of Taipei Economic and Cultural Office. It's a whole bunch, but basically I'm the Consul General of Taiwan here, serving the area of Colorado and the other 5 states in the Great Plains. I came here this morning and listened to all the talks. Frankly, I can barely understand 10% of what you've been talking about. But one thing is for sure, I'm here to showcase the commitment and support to Taiwan for 5G, for the Open RAN 5G and 6G development, and also the commitment of Taiwanese government to work with like-minded countries and the all capable, very flexible suppliers, company, vendors, whatever in Taiwan that you've just been hearing from Dr. Zhao, and stakeholders like ICHI, for example. for a more innovative, democratic, economic, and also interoperable network environment. And also through our cooperation, again, with like-minded countries, we would like to promote Open RAN to emerging and also developing countries through cooperation like in global cooperation and training framework, GCTF. So my job really is not to know more about Open RAN, but to facilitate these kind of cooperation. So if you're interested in collaborating with Taiwan, talk to people like Dr. Zhao, or I'm just in Denver, approach me, and I'll try to be the best facilitator you can find. Thank you.
All right, now we have the Ministry of Internal Affairs and Communications, MIC, from Japan.
Good afternoon, everyone. My name is Akiko from Japan's Ministry of Internal Affairs and Communications. At MIC, our mission is to drive technology forward and make sure it's accessible to everyone in Japan. We are also focused on promoting these advancements abroad to help boost economic growth and security. One of our main priorities right now is pushing for Open RAN technology on the global stage. Open RAN is key for diversifying the vendors in our digital infrastructure. This not only strengthens our supply chain and cybersecurity, but also prevents over-reliance on any single vendor, a problem known as vendor lock-in. By encouraging transparent and positive competition, Open RAN helps cut costs, reduce energy use, and build more secure and resilient supply chains. We are working closely with international partners through initiatives like GCOT and Quad, with a special focus on strengthening our ties with Asia. For instance, in 2022, we helped set up the Asia Open RAN Academy in Manila under the U.S.-Japan Competitiveness and Resilience Partnership. Since then, over 2,500 students, engineers, and industry professionals have taken part in courses provided through partnership with 14 universities in the Philippines. This year, during the Japan-US-Philippines Summit, Japan and the US committed at least $8 million to support Open RAN field trials and academy. Beyond the Philippines, we are also involved in similar projects in countries like India, Cambodia, Indonesia, and Vietnam. These efforts include field trials and proof of concepts initiatives, and they are all part of a broader strategy to promote Open RAN globally with the support of Japanese companies like NTT Docomo, Rakuten Symphony, NEC, and Fujitsu. In Japan, we are maintaining close public-private partnerships to ensure successful Open RAN deployment, coordinating with companies and other government ministries to achieve effective results. So there are more to share our implementations, but I will stop here. I hope we can come up with some great ideas and new collaborations. If you have any questions or want to explore further opportunities, please don't hesitate to reach out to us. And we are ready to work with you for the further deployment of Open RAN. Thank you.
Our next lightning talker is from MITRE.
Hey, my name is Rob Smith with the MITRE Corporation. I'm pinch hitting for a pinch hitter here, so bear with me. Do I have a slide or just a splash screen? Great. So what I'd like to take these 3 minutes to talk to you all about then is why dynamic spectrum sharing is a really important use case for O-RAN. And when I say dynamic spectrum sharing, I'm not talking about 3GPP, dynamic spectrum sharing, but the coexistence of federal and commercial systems in the same spectrum. So a lot of what we do at MITRE in support of NTIA and also in support of DoD is try to look at how can we make more efficient use of spectrum, obviously a critical national resource. And for those who follow spectrum access in the US, you know that DoD is a major holder of spectrum, and they're looking for opportunities to show that they can continue to use that spectrum while still allowing commercial enterprise to take advantage of it. So what we're really interested in with O-RAN as an enabler of dynamic spectrum sharing is how we can emulate a model for spectrum sharing that you might think of as sense and avoid. Some of you might be familiar with CBRS, where it's the responsibility of a kind of third-party system to detect the presence of a DoD incumbent and say, oh, there is a user here. I need to vacate this spectrum so that they can do their mission. As soon as they're gone, I get to come back and use the spectrum. And we know that this spectrum access is really important for the commercial carriers. We heard multiple times today that if you want a greenfield O-RAN network, you better give me fresh spectrum to build in, or there's really no point to do it. So that's why we think it's important. Some of the enablers of this for O-RAN, from a sensing perspective, some of our academic partners are interested in having access to IQ at the RU level for signal detection and classification. You might hear that in terms of a DApp. So there are people here today that I'm sure would love to talk to you about DApps. But there's also opportunities for measurements made at the RAN to be propagated up the stack to the near real-time RIC, or potentially even to the non-real-time RIC to do incumbent detection and classification. I guess last thing I'll say is we also need the network to be able to adapt its spectral footprint once it figures out that there's an incumbent present. So if we want to do that, we need the open interfaces, we need E2, we need access to the scheduler. We need these hooks exposed so that in an O-RAN context, we can manipulate the spectral footprint of the commercial systems so that DoD systems and other types of systems can get along with 5G. And that would be a big boon for the US. Thanks for listening to my lightning talk.
All right, moving right along to the National Institute for Standards and Technology, U.S. Department of Commerce.
Hi, I'm Doug Montgomery from NIST, in particular the Communications Technology Laboratory. NIST has a wide spectrum of research in the area of wireless, from fundamental measurement science, test and measurement research and development, and all of it has a strong focus on contributing to consensus standards in the O-RAN environment and space. We're very focused on looking at O-RAN interoperability and coexistence issues, RAN intelligent control. NIST also, at least in the US, has a strong mission component focused on security. So we have projects that are focused on enhancing the security posture of O-RAN in general, bringing concepts and technologies like zero trust architectures to O-RAN, evaluating how to architect those into the standards, and also evaluating their feasibility to actually be deployed. We have a wide range of collaborations, both with other government agencies, DHS, S&T. Quite often we interact with multiple agencies trying to coalesce US government requirements and objectives in the program. Also very involved in standards across a wide range of forum, the O-RAN Alliance and NextG Alliance through GPP, TIP, and IETF, where many of the security standards for O-RAN actually originate. We also interact a lot with the federal R&D community through organizations like NITRD and the Large Scale Networking Working Group, and the Wireless Spectrum Research and Development Working Group. These are the government research agencies where we coordinate programs, look to share direction, sometimes have common initiatives and workshops. Our interest in testing, NIST has a wide and long history in product testing programs and certification programs of varying forms and levels of formality. In the O-RAN context, we're focused on looking at the emerging testing ecosystem as it might be used by the federal government, either through certification of policy initiatives or acquisition and programs, and the level of formality and rigor that's needed there. Also, we're looking at testing programs from a security perspective in the way that you would want to certify or get the authority to operate O-RAN systems. What we think we can bring to this workshop is, as I said, this experience in testing programs and help refine, at least in the O-RAN Alliance community, their view of testing, and maybe recognize that there are multiple forms of testing with different incentive models and different labs that are interested in performing those different forms of technology. And I think they all need to become more well-defined and articulated. Thank you.
All right, we're down to our last federally funded lightning talker. If you are an academic lightning talker, please stand up and head over to the side of the room here to get organized. We will begin the academic talks with ARA Power Lab. But for our last federally funded lab and organization, it's the Ministry of Science and ICT, MSIT, from the Republic of Korea.
Good day. Sorry. Good day, everyone. My name is Jung Ro, representing the Ministry of Science and ICT, Republic of Korea. Today, I will present Korean government's strategy for the promotion of open land. MSIT is taking a comprehensive approach from securing the technical capabilities to commercialization and governance building. First, in terms of technology development, we are focused on advancing core-oriented technologies, including equipment, parts, software. In order to achieve this, we are engaged in international collaborative research with leading institutions such as Northeastern University in the US and other global partners, let alone domestic research projects which amounts to $2 million in total. Second, we are laying the groundwork for commercialization. Last year, we have established KoreaOptic to provide free testing and certification for open-land equipment produced by small and medium-sized enterprises. Moreover, 2024 will be the first year of Korea's commercial network open-land deployment, as we embark on a field test project in 3 regions led by telcos. Third, we have been bolstering public-private and intergovernment collaboration with the launch of the Open Land Industry Alliance, which comprises over 30 members, including telcos, vendor, software companies. We expect to foster a robust industrial ecosystem. On the global stage, we are working with key countries like the United States, United Kingdom, and Japan to promote the adoption of open land on a global scale. Last year's participation in Vietnam Ice Steel Show was a part of our effort to raise awareness and support the expansion of open land in emerging 5G markets. Looking ahead, we plan to continue our collaborative efforts focusing on training, research, and commercialization to ensure the successful global deployment of open land technologies. Thank you.
All right, kicking off our next section of the agenda is all of our academia lightning talks, starting with ARA Power and OTIC North America with Iowa State University.
Right, good afternoon, everyone. My name is Hongwei Zhang. I'm a professor of computer engineering at Iowa State University. In case you may wonder where Iowa is, that's between here and Chicago, about halfway. So I'm here to share a few words about one of the power platform, also one of the OTIC in America, which is Aero Power and Aero OTIC. So the focus of Aero Power as a living lab and also Aero OTIC as an overall related organization is focused on the far edge wireless network that you would find potentially in the near future in the rural areas, agricultural farms, and potentially in the technical field, right? So there are a few reasons why we look at this direction. One is, of course, the society challenge we see today about we need to connect about 30% of the population that are not well connected today. So there's that society need, but also rural regions actually, as you may or may not know, is the area where that actually some of the most advanced technologies get tried out first. When you think about rural, it's not always regions that's lagging behind. One example is I want to share here is that if you think about vehicle automation, we are still talking about it for the road transportation, but the vehicle automation in agriculture has been there for decades. It's running for enabling inch-level accuracy of kind of steering and so on. So there are similar examples you can think of for advanced wireless. For example, think of teleoperation of drones and vehicles or XR-related applications. So therefore, to address the society needs, also to leverage the opportunities provided by the rural communities and industries, we are running the aerial power testbed, as you can see from the upper right corner of the slide deck. So far, half of what you see here has been deployed and operational, covering an area of about 300 square miles in central Iowa. So in the testbed, you can find state-of-the-art radio access network platforms, as well as XHAL platforms, so that you can experiment integrated access XHAL and also actually non-terrestrial networks in the same setup. So as an academic OTIC, we actually focus on look at some of the research opportunities in the O-RAN space. For example, here you can find end-to-end programmable open source platforms that's available for you to try out more radical innovations in the space. In addition to that, we do have a focus about the use of advanced wireless in agriculture. So therefore, we have also been deploying state-of-the-art COTS platforms and have them used by the ag industries and also the construction industries to try out advanced applications such as agriculture automation and teleoperation. So looking forward, we would very much like to invite you to try out, work with us, try out some of the advanced solutions using the fully programmable end-to-end platforms. We would also welcome the opportunity of working with some of the emerging O-RAN providers, vendors, to actually deploy your systems in this state-of-the-art outdoor environment and try them out with actual real-world applications and users in the loop. Thank you.
All right, next we have Asia Open RAN Academy.
Yeah, good afternoon, everyone. I'm Tony Torres from the Asia Open RAN Academy. So basically, we are an activity under the IPA project of the USAID. We were incorporated last year, and IORS actually is the headquarters for the academy that will serve the entire Indo-Pacific region. We've done a lot of promotions and advocacy through our webinars. We have already have 15 courses that we will be sharing to the rest of the Indo-Pacific partners. We have, at this time, we have 14 university partners and other upcoming state universities in the Philippines. We have 3 government agency partners, 7 international partners. I saw E3 here and MIC and rest. And we have a lot that's being lined up. And actually, at this point, we are preparing for the operations phase because the USAID grant is about to end, and it's the board's role actually and responsibility to ensure sustainability. Open RAN is not yet that famous in the Philippines. In fact, we're having problems with the spectrum, and our major telcos joining this revolution. But in terms of our first academy, we are like confident that we can also partner with other state universities, even in the US and in other areas, to deepen our courses and technically produce the workforce that the Open RAN the Open RAN movement will require. At this point, we just done with our annual strategic planning, and if our own telcos will not be ready, then we are ready to ship our workforce, our developed workforce for the rest of the countries who will be needing them. And we are, in fact, contributing in the building of the Open RAN ecosystem in the Philippines, and we will continuously advocate for Open RAN. It's another open source movement that we have started in my previous career up to this point. And for all other details, feel free to visit our website, our Facebook page, our LinkedIn, and our YouTube. We already have uploaded videos of our 15 courses in the YouTube. Thank you.
All right, next we have CCI Virginia Tech XG Testbed in OTIC, Washington, D.C. metro area.
My name is Dr. Luizio da Silva. I currently serve as a Commonwealth Cyber Initiative Wireless XG Testbed Director. We are located in Washington, D.C. Next slide. Basically, we are our O-RAN testbed located in Washington, D.C. metro area. We have today 2 sites. One site is in lab located indoor in Washington, D.C. metro area that is enriched for SDR-based ceiling grid network, okay, where we provide remote access for the SDR. You are capable to deploy your own 4G LTE networking, your 5G networking as well, and the end-to-end O-RAN ecosystem using software-defined radio. The second site is in the field, located in Virginia Tech main campus, that is 4 hours and a half from the Washington, D.C. metro area. There, we are one of the few solo universities in U.S. that holds the CBRS priority access license that operates in 3.5 and 3.7 gigahertz. To explore this PAL license or commercial spectrum CBRS, we have deployed a 1.5-mile corridor in Virginia Tech main campus with 3 base stations located in the rooftop of 3 buildings on campus. And to explore as well the SDR experimentation, Virginia Tech has developed for the first time open source spectrum access system that has been using to test the end-to-end, to do experimentation end-to-end in the CBRS ecosystem. We are also a OTIC center in the Washington, D.C. metro area. The lab is enriched with mainly with key site test equipment and also with harness harness. We serve as well as a platform, okay, for not just for experimentation, test, and evaluation, but mainly with the focus on workforce development and wireless communication advanced. And all the students that work with us, PhD, MS students that work on top of this test bed, is mandatory for them to develop. In the end of that is a prototype, a proof of concept that really using real equipment, COTS-UEs, can be SDR, and real base stations. I am open for questions you have. You can talk with me in the break sessions. And you have also the address of the CCI testbed that you can access online. If you need more information, just reach out to me. Thank you.
All right, we're getting to the end of the academic. We're getting there to a break. Kyunghee University. Now, just want to double check that the speaker is not here from Kyunghee University. I don't believe he or she is in the room. Okay. Well, the slide is up on the website and here momentarily. Next up is University of Leeds.
Good afternoon, everyone. Syed Zadi from University of Leeds. I cannot explain where Leeds is as conveniently as my colleague explained where Iowa is. We are potentially, if you have heard of Manchester United, then I use that as a reference. If you know where Manchester is, we're sort of east of that 40 minutes, basically. I think it shows on the map where exactly we are placed in UK. So I'm speaking on behalf of 3 different initiatives in UK. So I'm talking about University of Leeds. We have about 4 different sites of O-RAN deployment, and we are deploying a mix of different software and hardware infrastructure. So we have NVIDIA's L1, L2 accelerated implementation of aerial O-RAN, which is being deployed with 1 indoor node and 1 outdoor node on the campus. And then we have a sort of a rural site, which is like a farm, where we are deploying 2 nodes, 1 indoor and 1 outdoor as well, for agrobotics applications, so similar to Iowa, as was mentioned before. Apart from this, we are part of one of the, I co-lead one of the 3 Future Telecoms Hub, which is equivalent of 6GIA or 6G hubs in Germany. So the hub is called Cheddar. That's the acronym, which basically stands for Hub in Cloud Native and Distributed Computing for Telecoms. So basically, we are looking at cloud native implementation, and we are particularly interested in AI implementation and AI ML framework for ORAN. So we have keen interest in how AI ML testing can be conducted for ORAN ecosystem, and we are interested in all three aspects: software, hardware, and the data itself as well. So can we automate the trials itself and capture the data or metadata for those trials, which can then feed into AI ML automation pipelines to do the testing, basically. So that's one initiative. I think in terms of Cheddar's detail, I think you can find them on the website. We have 3 different pillars, and we work across various different areas. We have 47 academics, about 47 PDRAs working on different areas, so I won't be able to cover all of that in 3 minutes, basically. The other initiative which we are part of is the National 6G Experimentation Facility, which my colleagues from Digital Catapult are also one of the nodes. The testbed is called Joiner, and this is something which is currently being deployed in UK to connect 11 different universities or 11 different sites, I should say, including Digital Catapult, to test solutions at scale. As part of that experimental testbed, we have spectrum brokering and lots of interesting options which are available at scale to do AI/ML type of trials, as well as orchestration and management trials as well. So that's really it from my side. Thank you.
Okay, thank you. National Yang Ming Chiao Tung University, NYCU.
Hi, good afternoon, everyone. My name is Xiao Xunwu, a professor with the EE Department of National Yangming Jiao Tong University. Previously, its name is National Jiao Tong University, the first university in Taiwan dedicated to the IC design and information technology. And I'm with the Institute of Communication Engineering, the first institute in Taiwan dedicated to the education and research of communication engineering. I'm the director of the research lab called Wisdom. At Wisdom, we dedicate ourselves to the design of RAN intelligent controller, in particular for enterprise Open RAN systems. And our mission is to advance the design of RAN intelligent controller, not just for network optimization, but also for quick deployment as well as automated testing. For this purpose, we work closely with our local companies, well-known communication equipment providers such as Compel and Picatron. And also we make use of the most advanced technologies like digital twin and AI/ML to design digital twin for the communication equipments. And in addition, we also work closely with our government-funded research lab in Taiwan, such as ITRI, and to design testing plan and programs, as well as conditions for the rig test of Open RAN. And also, based on the digital twin technology, we built, we call it network digital twin, to make sure that we can simulate the true experience of users in the network. And with the digital twin technologies, we can simulate lots of data in the real test environment that allow us to build AI native RAN intelligent controller, also allow us to evaluate the network performance before real deployment, and to make sure that the testing programs and the testing plans that we design comply with the international standard. We also work with VRV and as well as ITRI to make sure that the test plan can be certified. That's pretty much what we've done for Open RAN Society. If you are interested in working with us, but I'll be around and let us know. Thank you.
University of New Hampshire Interoperability Laboratory, UNH-IOL.
Thank you. Hello. So to continue with the introducing where we're from, I'm Lincoln Lavoie from the University of New Hampshire Interoperability Lab. We are part of the US. We are not part of the UK, but we're all the way on the East Coast. We are a leading independent interoperability lab. We're a strategic resource for a huge number of companies around the world, probably about 288 or so, spanning across 30 to 40 different technology fronts. In the ORAN space, we're specifically a ORAN Alliance OTIC. We are the lead for the PlugFest series, and we have been doing that for the past, I think, 3 years or so. Overall, this year, we're really focused on continuing to grow the integration efforts between a lot of the open source projects, working closely with tool vendors from like Viave and Keysight to really actually provide the industry with something that is going to be hopefully the reference blueprint out there for how these systems integrate and combine together overall. That's being published up as a number of Ansible scripts to an open source repo that will be coming available as part of this fall PlugFest. And then we're looking to actually integrate that with a set of CI testing that continuously focuses on that integration to actually bring out that overall research there. So we're very interested in collaborating, continuing to grow those test beds and promote that interoperability across the ORAN Alliance-based interfaces. Happy to have any discussions for how we can engage and kind of continue that effort here today. So thank you.
North Carolina State University.
Hello, everyone. Good afternoon, actually. So I'm happy to represent NC State here. I kind of wear a few hats. I'm an assistant professor with the EC department at NC State. I also serve as the outreach director for AirPower and the lab director for NextG Wireless Lab. So we are home to the third NSF Power testbed called AirPower, which I hope you all are aware of. It's a platform for advanced wireless research. There are 4 of them in the country. We're also home to 2 ERC centers, possibly the only university in the country which hosts 2 ERC centers. One is focused on wearable and implantable systems. So that makes a really good use case for ORAN. And one of the reasons why ORAN hasn't really succeeded is the lack of emerging use cases. And the second one is the smart grid, which is freedom. We recently also won the cloud for $50 million as a part of DoD microelectronics, which will advance semiconductor research. So back to the OTIC lab, we do support ORU conformance testing, end-to-end G-Node testing, interoperability testing, and we also have the right to issue certificates and badges. We recently tested a US-based ORU vendor. We are still accepting equipments until the end of October, so if you guys are interested, we'll be happy to work with you. We do plan to integrate rig testing, ODU testing, and others. Our current collaborations are with AORA, Asia ORAN Academy. I guess that they are trying to become the new OTIC with the ITRI. We also support digital twin. It's mostly focused with the mobility as the center of the digital twin. And as a part of NextG Lab, we do have a number of R&D activities. We recently released ORAN Benchmark that basically allows you to evaluate various LLMs for ORAN testing. We recently developed ORAN Site, which is fine-tuned for ORAN specifications that outperforms the Llama, the ChatGPT, and other platforms. Gemini is already available online, so if you're interested, you can check it out. We'll very quickly release ORAN test bench so that you can test the AI testing tools. One of the issues that we discussed today was the lack of publicly available test cases. So we are working on that. We are trying to make test cases available without manually going through the 3GPP specification, a specific specification within a specific clause. So we want to fix that problem so that you don't have to manually go through all that. And as a part of NTIA testing R&D effort, we are basically building all those efforts, the ORAN bench test mark, ORAN site, ORAN testing framework. We have a number of other R&D activities, as you can see there. So I'll be here around, so if you have any questions, please stop by. And I would like to ask Margaret, our platform director, to wave her hand, so you can either reach out to her or reach out to me or send an email, and we'll be happy to talk to you about potential collaborations, whether it's on whether it's a part of Plug Fest, the fall Plug Fest, or something else. Thank you.
Pennsylvania State University.
Hello, my name is Syed Rafil Hussain. I'm an assistant professor at Penn State, and I lead the Systems and Network Security Lab. So today I'm going to talk about our project, ORAN Analyst, an end-to-end security testing framework for Open RAN or ORAN implementations. So our testing framework is guided by the philosophy of security by construction. That means we want to consider security as a first-class citizen from the very beginning of design and development of Open RAN. So with that in mind, we have this developed new security testing framework based on designing new techniques, dynamic tracing and static program analysis based techniques that can automatically test any microservices for Open RAN. So next, please. So basically, it can test the memory corruption vulnerabilities, which can lead to crashes or denial of service problems. We can support grammar-guided and dependency-aware testing because Open RAN has many different microservices, and there are a lot of complex interdependencies between them. So we can solve that problem, and we can test multiple microservices at the same time. We can support multiple programming languages, such as Go and C programming languages. I mean, microservices are based on different programming languages. So far, with our tool, we have tested 2 open source Open RAN implementations. One is official Open RAN implementation of ORAN-SC and SD-RAN, and we uncovered 19 zero-day vulnerabilities, which are very critical, and we help the developers to fix these vulnerabilities. We have also a strong track record to perform the security testing in a black box setting. That means we don't need your source code. If you have the input-output access, we can also run any security testing. Next, please. So currently, we are also working on testing logical or functional vulnerabilities, such as authentication bypass. We are also working on testing RU, DU, and CU, and also supply chain security issues, such as analyzing or testing the software bill of materials for Open RAN. And based on our security testing, we are going to compile and deliver the comprehensive security conformance testing, which is currently not present in the ORAN specification. And we also believe that not only security testing before deployment is important, but also after deployment, there should be some kind of runtime monitoring that can continuously check and monitor the security health of your deployments, which is guided by the zero trust policy. And with that, I'd like to conclude my talk, and we are open for collaborations. Thanks.
Thank you. We've got 2 more, and then we're going to take a 10-minute break. Powder Lab, University of Utah. We might only have 1 more. All right, Rutgers University.
So, good afternoon. My name is N.K. Shankar, and I'll tell you about Rutgers University WinLab. Most of you probably are familiar with this. If you have not, Rutgers University is in New Jersey on the east coast of the United States. A very long history of wireless R&D, a very strong research program. WinLab is Wireless Networking Research Center. It has a separate facility, both strong in theoretical and experimental research and testing, and also a strong connection to the industry. And one example of me, I'm a research scientist at Rutgers WinLab now, relatively recent, about maybe 1.5 years. Many of you might know me from a very long career in the industry. I was with AT&T Bell Labs and then AT&T Labs doing research and then deploying solutions in AT&T's network. And so a place like Rutgers is somewhere where I feel at home, both research and the industry connections. Rutgers' WinLab is known for many things. One of them is the Cosmos project. It's a very state-of-the-art test bed, both indoor and outdoor. The outdoor transmissions include transmissions in New York City for research. It's a joint collaboration with Columbia University and NYU. Lots of topics. You can look at the website, software radio, millimeter wave, edge networking, cloud networking. And Rutgers has been involved with Open RAN and ORAN since the very beginnings and hosting plugfests and proof of concept since 2019. And so it makes sense. It's one of the early North American OTIC sites advocating for consistent testing and also open source solutions even before ORAN. And actually, the ORAN software community open source lab will be moving to WinLab. In this conference, I'm here with NTIA. We have two of the funded projects from NO4-1. I'm leading one of them, co-leading with Ivan Seskar, that many of you know, and it's a joint project with ONF and LF. This is on ORAN energy efficiency testing, and what I would like to collaborate with is we are developing test methodology and models for energy consumption because energy efficiency is so important, energy savings is so important. And so we are developing methodologies and models, but we would love to repeat our tests in other labs in different profiles to refine our models. The other big project is WinLab is part of the NTIA-funded Accord project led by AT&T and Verizon. That's leveraging its OTIC role. Happy to talk more with you with any of these topics, but mostly I'm focused on the energy testing efficiency part of ORAN and representing Ivan here on things related to the OTIC and Accord project as well. Thank you.
That was lightning quick. We are back on schedule. So we have a bit short of a break. Please come back at 3:37 p.m. It's about 10, 11 minutes away. All right, ladies and gentlemen, that was a very quick break. Apologies, but we are going to sprint to the end. We have industry lightning talks. And we will break this up into two groups. I already said from Airspan down to Mavenir, please line up. And we will line up the second group as we get to the very end of that first group. So without further ado, let's bring up Airspan for the first industry lightning talk.
Thanks. It's the last session. People, hang in there. I want to introduce Airspan to the team. I'll preface this by saying about 3 months ago, we were lucky enough to land $95 million of financing. And so you can understand that I've told this story several hundred times, to get to this point. And maybe the theme of this session is Open RAN, and the investment thesis behind the investment coming into the company was, in fact, taking advantage of the market inflection, the innovation around Open RAN. So who is Airspan? Airspan is a US-based Open RAN vendor, quite global. We have a development organization in the US and in Israel, in the UK, in Bangalore, India. And we have a customer base that is also quite global. We also, I would say, punch above our weight. In the last 10 years, we've shipped 1 million radios. So roughly 100,000 radios a year to a variety of customers in a variety of different technically challenging circumstances. We like Open RAN because it's open and because it's programmable. And the degree that it is programmable allows us to compete against the big guys. It's pretty tough for an Airspan to compete against an Ericsson or a Nokia, but if you've got an open programmable system, it means you can do things to customize the solution to be able to take advantage of a platform, but through that customization, do things that deliver certain capabilities that are difficult to duplicate for the big guys. And so we've got a variety of customers that we've been able to take advantage of, with that programmable system. We've shipped 250,000 radios into Reliance Jio very high capacity system. We've shipped 90,000 radios into Rakuten. The first global Open RAN system, at least that I'm familiar with, is Rakuten. We shipped 90,000 radios into Rakuten. We have provided an end-to-end solution for GoGo. So Airspan provides the baseband, CUDU. We provide the open radios. We provide the UEs, the user equipment, and the CPE. And we provide the management system that pulls it all together. We provided the solution for GoGo in unique spectrum bands. It's an air-to-ground solution. You have to solve technical problems that are very hard to solve. A distance problem, because the airplanes are a long ways away from the ground stations, and a velocity problem, the Doppler shift, because the airplanes are going super fast. So we have a unique capability that we want to take advantage of. And then finally, we do a lot of private networks. We've deployed over 500 private networks over the last 3 years, and private networks takes advantage of the programmability, the openness of Open RAN. So going forward, hopefully we can be partnering with some of you. Thanks.
All right, next up we have Booz Allen Hamilton.
Hello, everyone. My name is Samuel Apia-Mensah, and I'm here to represent Booz Allen Hamilton. For those of you who don't know what Booz Allen Hamilton does, we are a military and government contractor that deals in intelligence and cybersecurity mainly. But I'm part of the 5G team, and I work mostly in 5G security. So you might be asking, why am I here? Well, I'm here to talk about the public wireless grant that we got around O-RAN security that we're working on. So next slide. Yeah, so with this grant, we were awarded, it was us and Virginia Tech as collaborators on this grant, and it's a period of performance for 2 years. So we're about almost a year in, and we have about another year to go. But I wanted to talk a little bit about the scope of the grant, what we were tasked to do, and where we are right now in that process going forward. So basically, we had 3 main drivers for this grant. One is to make sure that we can drive advanced security testing for sophisticated O-RAN attacks. That was one of our goals, and we want to get that into the specifications going forward, hopefully that it can be adopted by the Open RAN community. Another thing is to increase industry and community adoption of advanced security tests for sophisticated attackers, and also through open source reference implementation and building. And then the third one was also to actually procure an O-RAN lab system and use that as our test bed for all our security testing and other further implementation validation. So at the bottom of the screen, at the bottom of the slide, you see a diagram of a lab deployment. That's the deployment we actually have in our Booz Allen office in Maryland. So we have this, it's an O-RAN system that was procured for this grant specifically, where we have the core system, where it's a Druid core deployment. We have the CUDU side of the house, where it's Radisys software deployment, and we have a Benatel radio that's connected over a 7.2 A split. So that's the lab that we'll be using to validate and test our work. So if you look at the other diagram to the left, that's actually covers the tasks that we are currently working, that we're driving towards our goals. So there are 2 main tasks. One is to perform threat modeling, security analysis, and penetration testing. So that's the first task. And the second task is interface fuzzing. So those are the 2 drivers for our current work that we're working through. So in the individual task blocks, you see on the left side are the current drivers, the individual activities that we're conducting. And then to the right is the output that we hope to get to at the end of this grant, which ends by the end of next year. There are you see some little circles in those blocks that shows the progress, the current work that we've done over the last year, and where we are in terms of status for each individual task. So basically, if you look at research task 1, we have looked at threat models from ORAN specifications, but also from industry models that are out there, that something like modified covers, and we've looked at those and try to analyze them and come up with ways in which we can look at the gaps in there and improve upon that in our threat paper that we are writing. So that's one of our tasks that we're doing right now. We're also doing things like looking at penetration of or penetration testing of ORAN systems. Making sure how do we analyze an ORAN system from a pen testing perspective? How do we make sure that we can secure it? Bringing up remediations that people can use and leverage in that task. So those are some of the things that the team has been working on over the past year. And then the next things we're hoping to get is developing some open source security tests. The second diagram just talks about some of the things we're doing around interface fuzzing, which goes into particular protocols that we're looking at around the ORAN system. So if you want to talk to me about it and get some more details about it, we can definitely do that later. All right. Thank you.
All right, next industry lightning talker, Cable Labs.
Thanks. Good afternoon. I'm David DeBrecht, Vice President of Wireless Technologies at Cable Labs. I'm pinch hitting for Mark Paletti, who you might have seen around. He's our director of our Open RAN activities. Unfortunately, he was not able to attend today, so I'll do my best to do it justice. Cable Labs is a nonprofit innovation and research center focused on the broadband communications industry. In addition to developing new technologies, which is a primary focus for us, a major part of the role we serve the industry is to guarantee compliance and interoperability for the industry. We have a long history, about 35 years, a little more than 35 years right now, of testing, certifying network elements, along with hosting interoperability events, doing industry vendors for cable, optical, Wi-Fi, and most recently, Open RAN networks. So we've been doing this for a long time. Open and interoperable systems for us is not a new thing. It's not something that came along with Open RAN or even mobile networks. It's been around for 35 years. As a matter of fact, if you've ever had a cable network to your home and had a cable modem or a Wi-Fi access point in your house, we probably still have that same exact cable modem in our lab doing regression testing and continuous integration testing on it, because we have generation 1 cable modems in our lab still that we're doing testing on today. The cable broadband industry has invested heavily recently on wireless technologies, including Wi-Fi, as well as Open RAN, because, as you know, the way we all connect to our networks these days is over wireless connections. Most people don't connect to their devices into a network by way of a wire. And in addition to that, our cable operators within our member group are actually the fastest growing mobile network operators in the U.S. right now, so very heavily invested. You also might have heard the name Curio. You see it up on the slide there. They're a subsidiary of Cable Labs, and they're responsible for the testing, the compliance, and the interoperability activities that I just described a second ago. So if you ever hear a company called Curio, it's actually a part of Cable Labs. For the most part, it's the same people doing the same function. It's just under a different organizational structure. Cable Labs was chosen by NTIA ITS as the host lab for the 5G Challenge in 2022 and 2023. We were the first OTIC in North and South America, and have developed and performed open plug fests twice a year for the ORAN Alliance for the last 3 years. We started back in 2022. We have plenty of learnings from all of that. We have 3+ years worth of learnings, some pretty sophisticated and detailed integration interoperability tests, and we look forward to having those discussions over the next couple of days and bring those learnings to everybody else. So thank you very much.
All right, next up we have Capgemini.
Hello, everyone. This is Chinmoy Sabut from Capgemini. So I'm very happy to be part of this growing global community. And on behalf of Capgemini, I can say that we are invested in this journey. We are committed to this journey. And since last couple of years, we are actually participated in multiple development, system integrations, multiple OTIC labs, NTIA Challenge, Plug Fests, and we are continuing this journey. what we bring to the table, we are very uniquely positioned in this journey. So as a key system integrations or integrators, we are actually trying to integrate multi-vendor systems to create a multiple blueprints which are ready for deployments, and which is one of the key asks of this community, that how we can deploy the proven blueprints. So this is where we provide our services. And on top of that, we have a huge system engineering and testing services. And since last couple of years, and not only from the 5G era, if you really go back to the 3G era, starting from the 3G era, we are also building I would say the very, very standard defined building blocks or frameworks. For example, CU, DU, implants. And if you really go to the full spectrum, starting from the implant to the RAPs, so our motto is to create which are very standard driven and which is very defined. And then those standard driven building blocks can be used by multiple players who actually want to build the products and deploy it. So we are actually collaborating with the equipment manufacturers, we are collaborating with CSPs, we are collaborating with the test equipment vendors, academia. So throughout the spectrum, we have something to offer. And in this particular consortium, since the whole ambition and the vision is that how can we go towards the open and trusted environment. So we are part of the different OTICs, and one of the very visible and prominent one is I14Y Lab. So we are part of that consortiums. We have actually played our role in validating multiple blueprints. So we have certain learnings in terms of the system integration challenges. We have learnings around the processes, and we have certain learnings that, okay, how we can make things better for all the players involved in this journey. So I'm joined with my two colleagues, Sandra and Monica there, if we can just raise your hand. So we'll be there tomorrow and day after tomorrow. We are part of the two sessions and happy to share our learnings to create these open and trusted deployment scenarios and for the success of the ORAN. Thank you very much.
All right, next up we have DeepSig. If you are an industry lightning talker in the list between Airspan and Mavenir, we ask that you come forward to the front and get lined up so that we know you're here, please. The next speaker is DeepSig. Okay,
yes, correct. Hi, I'm Tim O'Shea from DeepSig, and so DeepSig is a startup. We're based in Arlington, Virginia. We actually got started out of Virginia Tech, but we've grown over the past 6 or so years. And really our focus is this intersection between AI and machine learning and baseband processing, especially in the physical layer, to help improve spectrum usage. So some of the things that we've been up to and that we're working on are really, first of all, focusing on software. We interface with DU and system integrators to help really drive performance in Open RAN. And we see this as really critical in closing the gap with existing solutions. We need the best spectral efficiency and energy efficiency if Open RAN is going to win. And so I think this is how we get there. So first of all, we're working a lot on this RAN digital twin problem, where we're taking a lot of drive data and captures of channel responses in different environments so that we can do a better job of testing and validating the air interface in ORAN systems, and then also using this to optimize functions in the air interface. And then, so bottom left, then you see we're working a lot on what we call Omnify, which is really learning functions within the RAN, especially in the L1. And one of those is the uplink receiver. There's a number of other ones around how you do beamforming and channel estimation. And these are areas where you really can close the gap on spectral efficiency with some of the primes in this area. So this has been a big focus for us. And we're continuing to go into how do you really drive multi-user MIMO and future distributed MIMO. And then we're also looking at kind of next-G technologies. So if you can actually change the standard in REL 20 or REL 21, how can machine learning really drive the performance of the RAN even further? And then lastly, we're doing a lot of work in spectrum monitoring. So basically doing spectrum awareness for what are the different emitters and EMI and other networks in your area, and doing real-time monitoring so that networks can react intelligently and share spectrum. I know there's been a lot of interest recently in the new 3 gigahertz band sharing, and I think this is very critical for that, but also for efficient O&M of Open RAN networks. So these are kind of the core technologies. And we're always looking for new folks to work with, new DU type applications or SIs, so we'll be happy to talk about this. And we're also getting more and more involved in the standards. We've been involved in ORAN Alliance, the ORPC, but recently we've been kind of leading some of the efforts in the AI RAN Alliance and also 3GPP now. So we're trying to really be a little bit forward-looking there, as well as Open RAN, of course. So thank you.
All right, and next speaker is Ericsson. We got you. Okay. Thank you.
Hello, this is Hasib from Ericsson. You must have heard about us today as incumbent vendor, existing vendor, not so willing with Open RAN vendor. So I represent Ericsson's at ORAN Working Group 1 and also in ATIS MVP. So let's see if I can change your mind. So currently, we are making everything Open RAN. All of our products are going to be Open RAN compliant very soon. And not only that, we are basically driving the Open RAN industrialization both within Ericsson and also outside Ericsson around our ecosystem. And I'll go back to it a little bit more. Let me just start with what we have in Texas. I'm from Texas. We have a state-of-the-art 5G factory. Many of you have visited there. It's building, Open RAN component, and it's not just Open RAN, but it's made in USA. So that's another aspect of it. So what are we doing in terms of the different ecosystem? So on the SMO side, we have the RApps, that runs on our Open RAN platform, which is the SMO platform. And you can see that on the green line there, the R1 interface. On the northbound of it, all of the third-party RApps, including the operators, and there are a few vendor RApps are also mentioned. And we have not just that platform, we also have the developer portal. We also have a very sustainable developer community, and we're building an ecosystem around it. And you can see the numbers. We have 26 members of RApps that are building RApps today. And you can have access to it directly to our developer platform, which means that as we are building R1 interface in ORAN, and we're putting that into our product, and then you will have, all the developer community will have access to it. So it's pretty dynamic, and it's a pretty robust and expansive ecosystem. And then at the end, last but not least, we are also in the Accord Lab, which is the NOFO 1 lab. That's also in Dallas. And we are also doing the open frontal interface interoperability with third party. So I'm here to basically answer any of your questions related to our ecosystem. If you want to be part of the developer community, just let me know. We'll connect you with the right people. Thank you.
All right, thank you. Next up is the European Advanced Networking Test Center, EANTC. Do you have a chance?
Yeah, hello. The name is a mouthful. Yeah, my name is Carsten Rossnöffel. I'm co-founder and CTO of EANTC. We're an independent test lab based in Berlin, Germany, and we are part of the i14Y Lab consortium that was introduced earlier by Andreas Gladisch from Deutsche Telekom. Beyond that, we have always had two main pillars for testing. One is interoperability, multi-vendor ecosystems. That's an area where you need trust from the vendors. You need to be trustworthy, do confidential testing to really get them to bring their latest innovations, not be fearful and not just defend their own space. And so that's an area where we run very large interoperability events. We've also run already 5 Plugfests with the ORAN Alliance. We're preparing the 6th one together with the i14Y Lab. And we'll have in total around 18 vendors, so probably it's the biggest venue worldwide. So that's our specialty, to organize these tests, not only in terms of plug fests, I don't like the term that much, but really to create reproducible, tangible, advanced results from the testing. And our second pillar is benchmarking. So we believe that the certification and functional testing can only be the first step in the ecosystem. To get to the real production readiness of the products, we have a long way to go in Open RAN, and we see our role as one of the labs to support this journey as efficient and quickly as possible. And that involves creating test plans, test specifications with the O-RAN Alliance and with the Telecom Infra project. That involves mastering the large-scale emulation environments that you need in the lab, not only real testing with a few UEs, but really stressing the network like it's going to be stressed in real life. Also testing reliability, consistency, security, manageability, all of the different areas. So that's our second pillar, benchmarking and realistic end-to-end testing. And as part of that, as I said, we are a member of the I-14 YLAB consortium. Our job there is not only run PlugFest, but also to automate the testing, because that is, as Andreas Gladisch has already said, the second problem for the ecosystem. The new vendors need to have a chance to get on board. Of course, the large incumbent vendors have a great advantage, and we like to test with them because they're very experienced, but we need to grow the ecosystem. It's too early to shrink it again by acquisitions. We need to grow it now. And that can be done by automating the test, by making things efficient, by making things cheaper, and enabling the vendors that do not have their own labs to run tests elsewhere at in an affordable way, and also in an efficient way. It can't take 6 months to set up everything. And as part of our engagement with the O-RAN Alliance and TIP, our role is also to make sure that the industry progresses and advances quickly enough. I think it's great that we see a lot of government spending budget now. But the question is, are we just going to mushroom a lot of labs that do the same baby steps in parallel? So our goal is to avoid that and bring other labs up to speed as quickly as possible. So that's also one of the services that we provide to help enable lab as a service in an automated way. And beyond by the way, we do telecom testing, but we're also involved in campus 5G testing, especially in Germany with our industry base. That's a very important area. So we have research projects with other big industry players in Germany for campus 5G deployments. And beyond Open RAN, we're testing many other technologies in the mobile core. For example, the applications space is very important with the Open Gateway Initiative and Camara. And that's probably something that is not, that's not so well known yet. You know, the infrastructure is at the core attention right now, but what about the application space and the platforms? And with that, I think my time is up. Thank you.
All right, thank you. And I think we might have a slide for EY. We don't have a speaker today, so we're going to go to Fujitsu Network Communications.
Good afternoon. I'm Ladan Pickering with Fujitsu Network Communications. We are located in Richardson, Texas. So I'm just a couple of hours from here for those that don't know where Texas is. So a lot of people know Fujitsu. Next slide, please. A lot of people know Fujitsu from our radios. Fujitsu is a pioneer in O-RAN, and a lot of radios that are deployed, O-RAN radios, come from Fujitsu. So that's where we are well known. But I'm here to tell you a little bit more about other things that we do. You know, we are in system integration, and we also have a full stack from DU, CU, SMO, and RIC. And we have also participated in a lot of NTIA activities. We were part of the 5G challenge, the first one, the second one, and also we are partnered with a number of operators and test equipment vendors on the NOFO 1 who won NOFO 1. We are supplying radios to their lab and providing expertise. My current role at Fujitsu is apps. So I'm looking at actually integrating apps, and one of the first ones that I'm working on is actually an energy-saving app. But the challenges, I think a lot of people talk about apps like, an app that you download on your phone or on your PC and it runs. But the reality is that there are a lot of challenges. And those are the ones that I'd like to bring up today. These apps generally talk to the RIC through interfaces. And on the R app side, there are this R1 interface that app will need to talk to the RIC. But the problem is that the standards are not really there. They're very high-level standards that are defined, but the detail that you need of those APIs that would work and allow you to interface with a third-party RIC are not defined. So we are doing a lot of changes and trying to build a software that can work with multiple vendors' RICs. So I encourage that we get these interfaces defined and standard so that smaller companies will not have such a hard time integrating their apps to the RICs. The other problem that we are facing is the SDKs. These apps are supposed to be unloaded on the SDKs and the RICs vendors' SDKs, but everybody has their own SDK and their own way of onboarding apps. So that's a challenge that we need to overcome. The other challenge that I see is that when we build apps that work with our stack, everything is great. We know exactly where the data is, and our DU and CU and our E2 nodes provide what we need. But the challenge comes when we are actually going to an operator's network and we are testing our app. A number of DU and CU vendors, they don't open up these interfaces and give us access to the KPIs that the apps need. So I encourage the operators to work closely with their DU and CU vendors and make sure that data is available. Because if the data is not available, those apps will not be able to do what they're supposed to be doing. So the data needs to be available. We need to be able to read them and write them. And I'm going to move quickly to what we need from the labs. The labs need to provide an infrastructure that is easy to use the infrastructure, such as cloud. I can go to Amazon, get the compute and storage that I need, and my software will work. But I don't believe any of our labs are anywhere close to that. So those are the challenges that we face. And when we go to these labs, we want to have a variety of different vendors so that we can test with them. I know that my time is coming up, so I'm just going to bring up that these labs that are funded by NTIA are a great way, such as the ORCID lab for app developers, not a company like us, but even smaller companies to be able to bring their apps. Thank you very much. I'm happy to talk to you about anything.
Thank you. Next up, we have Global Star.
Hello, everyone. My name is Luis Mirabal. I represent Global Star. Global Star is a satellite operator, which is weird for an O-RAN. But last year, Global Star bought a company called XCOM, which I come from. And XCOM built O-RAN-based 3GPP solution that does distributed massive MIMO. So we support, in an area like this, probably about 4 radio units, and these 4 radio units will have 4R, and all the signals are synchronized and calibrated in a way that you can get peak rates for all the devices in the network. We build this stack from the ground up, and we have integrated with multiple cores. We have multiple UEs, and GlobalStar brings to the table something that is super interesting, which is that GlobalStar has terrestrial authorization to operate networks in band 53. 3GPP band 53 is 10 megahertz of spectrum in 2.4, 2.5 gigahertz. So on top of XCOM RAN being a super RAN network that can supply to the very high KPIs applications, we can also bring our own spectrum. And by bringing our own spectrum, we are looking forward to deploy cellular networks more like Wi-Fi. We are testing our platforms over 60 days continuously, running about 4,000 tests every time. One of the things that we do is mission-critical applications for the government and for warehouse automation, and the systems cannot go down. So that way, we actually ensure that the system works. And we're looking forward to test more devices and more applications. We are opening the ecosystem of Band 53, so we can have more suppliers of UEs and applications, and we are opening an innovation lab in San Diego, California, starting next year. We're going to bring applications and test cases and usage tested with our networks and tested with other networks to augment this ecosystem that will use this additional spectrum band available to all of us. Thank you.
All right, next up, Hewlett-Packard Enterprises.
So this kind of feels like ORAN speed dating. I don't know, at least for me. So thank you for having us. So I represent Hewlett-Packard Enterprise. That's HPE, not HP Inc., which is the laptop printer company. This is the server storage company. So just to make sure that you know who we are. So we started the ORAN journey back in 2017-18 when we deployed our server for the DUCU with the U.S. Tier 1 operator. Now we have deployed in Japan, in Canada, in U.S., across the globe. And, a lot of it comes down to you look down, from 2017-18 all the way down, and then you say, okay, why didn't ORAN take off? Why is the adoption slow, right? And we talk about testing and, what we need to do for testing and so on. But then you look at the challenges that the operator has, and we need to address all of them. I mean, particularly the TCO. Everybody talks about TCO. We cannot adopt because, you look at the traditional RAN and you look at the Open RAN and the TCO is not there. Or system integration complexities, operational complexities, okay? So we need to address that as a team, as the ecosystem team, okay? That's what HPE does. What we do is we work with our ecosystem partners. That's the key thing for us. Whether it is, just taking the simple hardware itself and making it an OEMable hardware for anybody. I mean, a lot of you in this room, whether you're using the hardware for testing, for DUCU testing, for the overall testing, DUCU deployment, you use hardware in some capacity. So we are the experts in hardware. And so you can OEM it, or you could just, use it in your labs. You could do anything with our hardware. And then from there, we facilitate the testing of the solution, of the system of the solution with the software, going all the way up to blueprints and all the way to automated deployments, whatever we need as a system, as an ecosystem, we help you get there. To the operators, to the partners, I mean, that's what we do. We do it in the non-telco space. We do it in the hundreds of thousands with customers, everybody from public sector to manufacturing, et cetera. And in telco, we have been doing this in the core, and now for the RAN, we're willing to help you. So we do have labs worldwide, by the way. Our main telco lab is right here in our backyard here in Fort Collins, Colorado. And we do have labs in Houston, Alpharetta, in Bangalore, Prague, I mean, you name it, around the world. And we have global reach around the world. So please, we're here for the next couple of days. Please talk to us, and, we'll see how we can help you. Thank you.
All right, next we have Juniper, but Juniper's not here. There's their slide. And Leica Wireless Solutions.
Good afternoon. My name is Rajani Pandrangi. My role is as director at Leica Wireless. So a quick word about Leica. We're a company out of Bangalore in India and a full RAN developer. So everything from 4G and 5G radio all the way through the protocol stack. I'll talk a little bit about that later. Company was started about 14 years ago. Has three main businesses: the RAN business, the industrial IoT business, where we make 802.16 S&T equipment, and the third part is SDR equipment, primarily intended for the military in India. We started the O-RAN in a different way, from the 5G solution in a different way from 4G, where we started making it with an O-RAN perspective, as opposed to the integrated RAN we had for LTE. And here we do the full, as far as we can see so far, full disaggregation of the RU, CU, and DU. And the protocols in between are open, so we support F1, the E1 interface as well between the control and the plane and the user plane. And the O1 interface to the SMO, which we make ourselves as well. Where have we actually done this interworking? We've interworked with MTI Group from Taiwan, where we connected their RU to our CU-DU. And in reverse, in the Indian Institute of Science in India, we connect our RU to an OAI DU as well. So both of those are ongoing. We're also, as part of the Indian government's initiative with CDOT, are interworking our CU with the third party's DU as well. What do we want to do next? Commercial deployment, of course, we are deployed in several places at the moment in India, but it's focused currently in India, looking to see where we can take it globally as an open RAN solution. We're not going any other direction. And finally, of course, we're also looking at how we can help out other, mostly educational institutions who have come to talk to us to see what we can do with this. Thank you.
All right, another speaker we might not have, LF Aether. Again, there's their slide. And again, you can find it on its.nta.gov on our IORS webpage. Next up, we have Lions Technology, Inc.
Thank you, Jeremy. Good afternoon, everyone. I'm Tony Huang from Lions Technology. It's glad to be here to introduce our company. Lions was established 5 years ago. We have an office in Taiwan, United States, and Japan. Although we are considered as a startup company in telecom equipment industry, but our team have averaged more than 15 years experience in mobile network, started from 3G and 4G small cell. So we are a small company, but we know RAN well. So currently, we focus on the providing O-RAN 5G radio unit, ORU, front-haul gateway, multiplexer, CBRS domain proxy, which is important for the private network in United States. And we also have the lightweight CU-DU for POC. We have participated in the O-RAN Plug Fest for 3 years, testing on front-haul conformance, interoperability, and end-to-end performance. Those activities actually give us the deeper and comprehensive understanding of CU-SM plan and give us the opportunity to make our design mature. So last year, we are honored to receive the 5G Challenge Award. And now we are participating the cohort 5 in UK in Sonic Lab. So beside those lab tests, we also work with the many CUDU partners together to make the front-haul IoT fast and efficient, as well as to work out the ideal throughput of end-to-end solutions. So by doing this, we believe we are toward the goal of ORAN multi-vendors. So Lions will be the part of the ORAN ecosystem. So if you are looking for the ORU partner, please come to us. Thank you very much.
Okay, now that we're down in Mavenir, if you are a speaker for Nokia down through Z-Touch Networks, please go ahead and line up at the front of the room over in the corner. That includes Viavi will be first in that group, and then Tip will be last in that group. Okay, next up is Mavenir.
Good to see you. Thank you. Hello, everyone. My name is Sridhar Rajgopal, and I'm representing Mavenir here today. So, as many of you may know, Mavenir is one of the leading Open RAN vendors. We are commercially deployed worldwide with our RAN products, both radios as well as the CUDU products are commercially deployed in many countries. So what I really want to talk about today is two things. One is why you should be collaborating with us, and the second part is what I look forward to discussing with you in the workshops at this meeting. So if you look at the amount of work we have spent in terms of integration of different components. So our CUDU products have been integrated with more than 16 radio vendors. And if you look at the number of band variants and software upgrades and things like that, it goes well into the 80s and hundreds of radios that we have integrated with our RAN software. Our radios have also been integrated with the tier one vendors like Nokia. I think we had a press release on that earlier last year. And we are also now with the trend towards intelligence. We have RIG products now available as part of our portfolio. But the key difference is we are not just looking at RIG from RAPs and the intelligence part, but also looking at it from the causation and explainability issues, which you can actually get when you apply artificial intelligence in terms of trying to figure out not only that you have to change your parameters or change or adapt your configurations, but also why these issues happen and how you can actually modify the system to improve the performance. And I think that adds a lot of value that we can provide to operators. If you're interested in working with us, I mean, we are right here in Dish, in Orchid. We have our products available. You're welcome to visit. I think there is some visit on Thursday, so you're welcome to visit that, and hopefully you'll get a chance to look at our products in there. We are also supporting the Accord program with Verizon and AT&T, so we have offered our solutions there as well. In terms of what I hope to achieve in this meeting today, I think we have been participating in many plug fests. I think over the past 4 or 5 years, we have participated in the 5G challenge for multiple years. But I think the time is now to move from the OTICs and labs to figure out how to actually scale. And when I scale, I mean when you're going from a lab or a small kind of over there testing to actually to field and commercialization over hundreds of sites, then how do you perform things like lifecycle management? How do you perform upgrades? How do you roll back? How do you take care of issues? How do you actually roll out, especially in a multi-vendor environment, because you don't have control over everything, and you have to work with operator timelines, you have to work with other vendors, you have to work with platform upgrades. And I think this is a good topic that I hope to discuss with many of you here at this meeting. So feel free to reach out, and I hope to meet a lot of you offline and have some discussions. So thank you very much.
All right, we are moving right along. Good news, we're halfway through the industry lightning talks, and then we get to talk about happy hour. Next up is Ian Wong from Viavi, slightly out of order, but Viavi is next. Thank you. All right.
Sorry for cutting the line. I feel bad. Hopefully all of you guys will still be our customers after this. But anyway, my name is Ian. I work in the CTO office of Viavi. We're a leading provider of ORAN test solutions. We've been collaborating across the entire ecosystem. All of you are, probably, know a lot of you and collaborate with all of you. If you, next slide, please. We have the complete ORAN test suite from the lab, a full set of emulators. You probably have heard of the TM500, which is a de facto standard for testing base stations used by all the major base station vendors around the world. But then we have a full family of emulators for RIC, for DU, for CU, for core, to test any element in the ORAN network. But in addition, we also have a full suite of field instrumentation tools. So again, getting ready for ORAN deployment, we have the world's first and only portable DU emulator for testing RUs in the field. And we also have a full suite of software solutions for operator maintenance and optimization. Clicking on, this is what happens when you can only have one slide, so you try to put 4 slides in one. And our objective is to put as many logos as possible in that little corner. But basically, we've been supporting the PlugFest since 2019, every single one of them, over 100 PlugFest demos since then. So chances are your logo is probably up there. Next slide. We've been supporting a lot of things, with the NTIA, with the 5G challenge and for the first and the second one. But more recently, we are very honored to have won one of the 3 test and evaluation labs as part of the NTIA Public Wireless Supply Chain Innovation Fund. So we're the only non-operator that have a lab. So the idea here is, this is a fully automated hybrid lab. It will be cloud and physical. It's actually going to be in Chandler, Arizona. It's the reason I'm cutting the line, because I actually have to fly out there tonight. I will be back on Thursday because we are actually doing a dry run of the ribbon cutting for this lab, which will be on October 7th. So many of you have received an invitation. I've been asked by our marketing team for you to RSVP because the hotel block is running out. So please do, October 7th, that's on Monday before MWC Las Vegas. If you have not received an invitation, that is really, I would say, our bad. But we are welcome to attend the ribbon cutting. It's actually open to the entire ORAN ecosystem. My colleague here, James Trin, is right there. He'll be more than happy to take your email. Attending the ribbon cutting is free, so there will be drinks and all that. So I just wanted to, but you have to pay for your hotel and transportation. Finally, for this workshop, I do want to, I did read the instructions, so I tried to put some thoughts on how to achieve consistent, repeatable testing, if it actually shows up. Next slide. So these are just kind of my thoughts. First of all, it starts from rigorous test specifications and making sure that our certification badging procedures are rigorous. I mean, the group that I chair in ORAN, the Test Integration Focus Group, we do our best, but we can always do better. So we are doing that today by coordinating across the whole ORAN. And I think Jeremy is about to kick me out, so just read the rest of it, and we'll talk in the next, on Thursday. I'll be back for a few sessions, and we'll chat then. Thank you.
All right, thank you so much. Let's keep rolling with Nokia.
Yep, thank you. Good afternoon, everyone. Maybe good evening. So my name is Jad. I'm part of Nokia, head of technology. So I know the Nokia, we might be also part of the incumbent, like Hasib mentioned. But no, hopefully we're going to change your opinion. So when it comes to ORAN, we believe there are 4 fundamentals, pillars for the success of ORAN. One of them is standards. The second is understanding the market requirement. And the third one is solution, a strategy solution. And the fourth one is executing on this. So when it comes to standards, we are heavily involved in the ORAN Alliance. We co-chair 3 essential ones: the front haul, the near real-time RIC, and the operation and maintenance. Now, what does the industry need? That's a good question, actually, we should ask. If we go back to the early presentation, I think the industry definitely wants to adopt ORAN, but there is a fundamental need for feature parity. And what is feature parity? Is whatever feature that we have today in our networks to be supported in the Open RAN architecture. And this is really important if we really want to have performance on par or better. And this is where we are bringing our solution, what we call AnyRAN. I'm not going to talk marketing, but our solution will bring from day one feature parity. Number 2, our ODU. Our ODU, and if we look at many baseband cards that are deployed currently in many, many networks, they are already ORAN capable and proven that they are capable not only in trials, but in 2 global commercial deployment. And our ODU also, we are involved heavily in this, in the NTIA NOFO 1, and hopefully the next one, NOFO 2. Now, I'm gonna talk about the near real-time RIC, and many of you are gonna tell me, it's like, what's gonna be the application of the near real-time RIC? I think someone mentioned it, and I agree totally with him, Andrew. I totally believe that the dynamic spectrum sharing, which is an essential part of the NTIA National Spectrum Strategy, essential for the 6G spectrum, gonna have the near real-time RIC as an application. Now, all of this is wonderful, but the question is how to execute on those solutions in a way which is persistent, in a way that we don't disappear next day as a vendor. You don't want to deal with a vendor that disappears next day. So that's why there is a need for trusted vendor and vendor which have the experience and the R&D capability in RAN over decades, proven. And this is what we bring to the table to our customers. And thank you.
All right, next up, we have Open Air Interface.
Hello, I'm Irfan Gauri. I am a board member at Open Air Interface Foundation, and also I co-chair the open source focus group of ORAN. So we are open source people, and that's why I'd like to speak about what we advocate, which is open source Open RAN. Now, some of the things that I may be saying over here are a little bit further out compared to what was said until now in terms of interoperability, deployment, and the repeatability of tests, etc. But first, maybe what I can tell you is, for those who don't know Open Air Interface, Open Air Interface has an offering for open source CU, DU, and we also have an implementation of the core network as well as the UE. Now, some of these components, especially the UE, is a next generation study component that is used by many, many universities, research labs to test the AI/ML type use cases. UE is an important component of that. But let me speak about why I'm here. I'm here to introduce an organization that has recently been incorporated, the Open Air Interface Foundation. It's been incorporated in the US in the month of June. And the reason that we have incorporated it here is because there's a huge community of users of open air interface software in the US, and some of the questions that we get at times, the gentleman from North Carolina was asking me, how do we contribute? So we believe that our presence here with an engineering team will allow us to foster this community, work with them closely, have them contribute into the OAI code base, and also we have another mission, which is that of educating the next generation of engineers in this area of RAN, Open RAN, and to build a self-sustaining open air interface community in the US. The other thing also is that, and that's totally related, is because of the fact that there's a lot of US public program investment in this area. This is the time when a lot of action is happening. Universities are applying for funds and doing research in this area. So we'd like to engage also with the US government organizations to work with them to develop the community here. Now, one thing that I will finally say is that when we speak about national security and also the next generation RAN and all the developments that are going to happen further down in 6G, 7G, etc., we need to understand that we need to raise the next generation of engineers. And we are fully invested as the Open Air Interface Foundation to work with you to deploy programs in universities in order to teach that next generation of engineers and to prepare them for our industry. Thank you very much.
All right, thank you. Next we have Parallel Wireless.
Hello, good afternoon, everyone. I'm Anand Bhaskarwar. I'm Executive VP and Head of Professional Services at Parallel Wireless. So Parallel Wireless is a US-based company which develops Green RAN solution that enables mobile network operator to leverage open platforms with reduced TCO and improved energy efficiency. So one of the challenges I'm discussing here today, and a lot of you touched upon it, is the IoT between a radio unit and a distributed unit, and especially when it is developed by two different parties within the ORAN ecosystem. As an ORAN supplier, Parallel Wireless is well acquainted with this challenge and encountered during various IoTs we have taken place. The most challenging aspect of this IoT is a control plane and a user plane integration. It is an iterative process wherein it requires extensive cooperation between both the parties, which involves identifying gaps, fixing issues, retesting it, and this is even after complying and reviewing the ORAN IoT profile. This is a huge effort. We estimate it's about 1 year in terms of calendar days, and it can cost you up to $1 million, considering all the human resources, time, equipments, etc. So what we're bringing to the table is we are proposing a solution to address this challenge through a platform. We are calling it as ITP. ITP is an interoperability test platform, which consists of set of lab equipment, predefined test procedures, preloaded IoT profiles, and automation software which we will be building, which will run a variety of test procedures and produce a comprehensive report which identifies all the gaps, and also a debug interface to easy troubleshooting. With ITP system, both RU and DU manufacturer can perform independent testing, the pre-integration testing, which minimizes the longer collaboration between both the parties and saving money and time, and ultimately improving time to market for the final product. Thank you.
All right, in case you haven't found an ORAN partner yet, don't worry, we have more speed dating to go. Our next lightning talker is Qualcomm. Thank you.
Good afternoon, everyone. It's nice to be in a room full of people that love Open RAN as much as I do. Okay, I want to talk about two things today. One is Qualcomm's role in cellular infrastructure in general, and then in particular, what we're doing with Open RAN. I was thinking this morning, it was almost 30 years ago I started working at Qualcomm. We were building CDMA base stations for 3G, mostly because the rest of the industry was skeptical. They didn't believe it would work. We had to prove it worked. We did. Once there was demand, then we could sell those parts to other companies. And we actually wound up selling the whole business to Ericsson a few years later, and they took it forward from there. So in every G, from 3G, 4G, 5G, hopefully 6G, we've seen demand from the operators for open interfaces in the RAN for a lot of the reasons that have been talked about that Open RAN makes sense. One other thing that Qualcomm has always seen as a driver for Open RAN is the ability to innovate more quickly and to get new features into the RAN more often than once every 10 years when you do a new G. So we're using the parts that we developed for 5G Open RAN already to build our 6G test beds and equipment for developing 6G technology. So back to Qualcomm's role in Open RAN. About 5 years ago, we started a project as the ORAN Alliance was getting underway to standardize the ORAN interfaces. We have developed commercial parts for both the DU and accelerator card and also the RU to handle the PHY processing and the RF parts in the radio units. And I want to thank the companies that we're working with there, our partners and customers that are using those parts. You can see on the slide here, we've got a lot of the companies that have already spoken today: Docomo, Viatel, Fujitsu, NEC, Mavenir are all working with us to commercialize these parts that we've developed. There's one other little section on the slide that talks about total cost of ownership. There was a study done about 3 months ago now that showed, I believe it was a 20% improvement over the existing platform over 5 years if you're using the part from Qualcomm. So again, I think this journey, everyone's talking about the Open RAN journey. If you look at the 3G to 6G journey, it's been one of constantly trying to open up the RAN and provide opportunities for new entrants. Finally, in 5G, we have the standards that everyone's talked about. I see a lot of my colleagues from ORAN standards here in the room as well. And I hope that towards 6G, we can use the baseline that we've developed here for 5G to make sure that it's also a fundamental part of the 6G infrastructure. Okay, I'm out of time. Thank you.
All right, next up is Radisys.
Good afternoon, everyone. My name is Ganesh Shanbagaraman. I head the standardization functions and take care of the ecosystem partnership along with regulatory affairs in Radisys. Can you go to the next slide, please? So about Radisys, we are a US-based company headquartered in Hillsboro, Oregon, with offices in other places in US, and we have centers in Europe and Asia, where we do a lot of software development. So we have been a pioneer in the software, RAN software, 3GPP and ORAN compliant, and all the open standards, including the SCF, Small Cell Forum, FAPI and FAPI standards. So we've been a leading supplier of open software over the last 2 decades, since 3G times, 3G small cell, 4G small cell. We ran in 4G and 5G. And the way we enable this market is through various partnerships. We have the broadest ecosystem partnership, multiple layer 1 partners, multiple RU partners, and chipset partners for our small cells. And we have integrated our software with various different hardware accelerators. And this is used as a benchmark. Our software is used as a benchmark to make sure that you get the complete end-to-end performance, not just the layer 1, layer 2 integration. And we also have benchmarked our software on multiple card servers when it comes to the CDU software. And we have been working with hyperscalers as well, both public cloud providers and some of the private cloud providers for various different solutions. And with integration of RIC, XApps, and RAP providers, we are enabling multiple use cases wherein you can bring in the elements of artificial intelligence and database analysis. So with this kind of partnership, we are able to enable many use cases of Open RAN-based software, and whether it's 5G, fixed wireless access, macro mobility for SA and NSA, and neutral host solutions, that is something that has caught pace in the recent times. And we've been enabling outdoor small cells and indoor small cells both in FR1 and FR2 spectrum. And this has been one of our strongest stories as a key enabler of small cell solution provider. And we also enable multiple use cases in the defense and private networks. And that is across continents, customers in Asia, Japan, and other places, Europe, and in North American continent as well. So our approach to enable this is to make our software feature rich and supporting multiple advanced features, and comp, energy efficiency, to support neural host solutions, MOC and MORAN, and we have enabled multiple TDD, FDD bands through the various interops, and we also support multi-carrier aggregation, multiple component carriers in both FR1 and FR2. And to enable CBRS deployments in the US market, we have been building in the functionality of CBRS domain proxy, SRS, the SaaS client, and so on, interoperating with the major SaaS providers. And with this kind of approach, we are able to enable the software through its versatility, right from the small cell footprint, wherein the software needs to be extremely optimized for constrained platforms, to a very highly scalable solution when it comes to the macro base station, whether it's a PNF or a CNF, and we also support network slicing and RIC-enabled use cases. So our idea is to become the trusted vendor, secure, interoperable, and fully scalable. Thank you for this opportunity. Thank you.
All right, next up we have Samsung.
Good afternoon. I am Ardavan Tehrani. I am Director of Engineering with the 6G research team at Samsung Research America, based in Northern California. It's a pleasure to be here and present and share Samsung information with you all. As far as who we are, many of you are familiar with Samsung consumer electronics products. Samsung is also a leader in 5G and next-gen infrastructure solutions. We are a secure and trusted supplier to the most technology-forward operators around the world. Samsung is also ranked first in terms of market share in ORAN and vRAN globally. This is according to third-party market research firms like Dell'Oro and Omdia, with customers including Verizon, Boost, Telus, Vodafone, KDDI, and NTT Docomo. As far as what we are working on, we want to highlight that Samsung has done more interoperability work across every layer of the stack other than any other vendor. In the interest of time, I'm not going through all the details. However, as you see in the diagram here, Samsung has had collaborations with prominent vendors and suppliers, specializing in different layers and parts of ORAN and vRAN, including prominent CPU vendors, server companies, cloud providers, OpenRU companies, transport layer providers, and our apps developers. We want to also highlight some of our Open RAN work with NTIA. Samsung is a member of two No4One consortia, Accord and Orchid. And I understand that there's a tour of the Orchid facility on Thursday. Samsung's Open RAN and vRAN systems are now installed at Accord Dorado Lab at UT Dallas. And we're also planning an open RU interoperability testing with ComScope as a next step in Q4. Finally, it's not on the slide, but I wanted to also mention that Samsung Research America has filed, and we have a pending NOFO 2 application. Thank you.
Sure. Thank you, Samsung. Next up, Solid.
Good afternoon. Very nice to meet you. My name is Yong-Hoon Kang, Chief Technical Officer of Solid Americas. Solid is 25-year telecommunication OEM vendors. Our business includes Open RAN radio, neutral host distributed antenna system, and fiber transport. Especially regarding Open RAN radio, we delivered more than 13,000 commercial radio units already globally to the US, Germany, Japan, and Korea. Regarding the testing, so we think the testing is very critical for Solid as a radio vendor to prove our Open RAN frontal is truly open. So we are actively participating the all multi-vendor IoT, including Blockfest in France, and Sony Lab Cost 2 in UK, and also Korea Optic. And also probably we are participating the Accord program and Baylor program, which is funded by NTI NOFO 1. So as a future collaborations, one of our interests is the multi-operator over ORU testing. This is for the RAN sharing or the infra sharing or neutral host application use cases, which is, I think, the most of the MNOs has keen interest of. So actually, ORAN Alliance is working on this standardization called shared ORU feature. But in terms of the ORAN radio vendor, we cannot develop or test or verify without the full ecosystem, including DU, test equipment, and SMOs. So we are welcome to discuss the ORAN industry to discuss how we test this multi-operator ORAN features. We are welcome to any collaboration discussions. Thank you very much.
Perfect timing. Okay, next up we have Tejas Networks.
Perfect timing.
Yeah.
Hello all, I'm Varun Kapoor from Tejas Networks, Vice President of Business Development. Responsibility is to define our portfolio product strategy for the Americas region. So let me first introduce what Tejas is. I think many of you may not have heard. That's what we realized during the discussion. Tejas Networks is a Tata Group company. We have and have been very fully committed to Open RAN strategy innovation. Tejas is headquartered in Bangalore, India. We have our offices here in the US, just outside of Boston. In the last couple of years, we have been actively engaged in Open RAN standardization efforts and building ORAN compliant radios. We currently, as of now, we have a large deployment going on in India. That's how we came into prominence in the whole wireless space. The deployment includes 100,000 cell sites, 4G upgradable to 5G. That's about 450,000 radios in India. We have built production capacity about 40,000 radios per month. Now, there are two core goals that the company is pursuing. One was to come up as a trusted supplier out of India with a supply chain chipset dependent on the US partners, which again very aligned to what NTI has been pursuing. The second one is to increase the supplier diversity, and then it matches with the Open RAN initiatives that Tejas follows. All our portfolio for the future products has been committed to be Open RAN compliant. On the contributions to Open RAN Alliance, we've been very active in the work group 6 on cloudification and orchestration. One of the areas to microservices contributions, as well as management of the hardware accelerator on the orchestration side. We've been also active on the OTIC partnerships, working very closely with the test instrument vendors as a feedback loop and aggressively bringing in the test strategies. And largely with the European and Asian OTIC, I had a couple of discussions today, and we'll pursue our OTIC engagement in the US as well. Then something else is happening now is we're also contributing to the next generation radio work groups. And that's all majorly on the hardware software disaggregation. And then one key pursuit is to actually follow our energy efficiency. We are coming with a platform-based modular strategy with the goal of having a standard platform on top of which several multiple SKUs for different geographies can be developed. Again, the reason is to actually use the scale efficiency of production scale, but then modify those SKUs. And so again, the goal is pursuing and maintaining the supply diversity ecosystem and ORAN compliance moving forward. So that's all from my side. Thank you.
All right, I believe we're down to our last three. VVDN. Oh, okay, you're here. VVDN, and then the last three. Thank you very much.
Thank you. Hello, everyone. I am Deep from VVDN Technologies. I'll introduce you about the VVDN technology first, as a lot of you guys are not aware about it. So the VVDN, as name stand for Voice Video Data Networking, we are divided into 5 business units: ACC, Networking, Wi-Fi, Vision and Automotive, IoT, and Cloud and Application. We, as a part of ACC group, we mostly focus on the telco-grade products, open end product. We have more than 30 radio SKUs. We have our CUDU, open end base. We have core. We have IMS. We have RIC. We have a complete end-to-end solution. And we mostly work with the OEMs. We are the ODM. We help to enable the OEMs across globe. Recently, we did a lot of commercial deployment, open-end-based commercial deployment, correct, in Korea, in one of them in US, and a couple of in India. As a part of current collaboration, we have done, we are part of 6G Bharat Alliance. We are part of Open N Alliance. We did a lot of sorry, I think maybe you're at the wrong page. Can you? Yeah. As a part of collaboration, we did collaboration with a lot of government entities across the globe. So one we have done with the CDOT. We are building the Bharat RAN. We are building the 88R solution for them. We did for we are working with DOT on the 6G Alliance. We did with TCIL on the 100 labs. So we deploy more than 100 labs, correct, across India with the multi-vendor kind of solutions, correct. So if you are having any query on the Open RAN kind of solution, or maybe looking for any kind of lab as a service kind of solution, we are there to maybe collaborate and help you there. So that's it from my side. Thank you.
All right, in the home stretch. Next up, we have Virginia Tech Applied Research Corporation.
So Viavi might have been able to jump ahead in the line, but I think I saw at least Virginia Tech's name on 4 different slides. So, it was a great strategy. If only the football team would follow that playbook. Well, my name is Michael Miller, Virginia Tech Applied Research Corporation. I'm the director of the Engineering Test Evaluation Division. It's one of 3 divisions we have there. Now, some of you might be wondering, why in the world do I have a picture there of the Ford plant, old Ford plant? Didn't he know that this was an Open RAN conference, not a automobile conference? The thing that's interesting about Ford is that Henry Ford didn't invent the car. I think most of us realize that. But he did enable widespread adoption of the automobile, right? Because he made it work and he made it cost efficient. And that's what we want to be able to do to help with at Virginia Tech Applied Research Corporation, is to help with wide-scale adoption of Open RAN. We know that it needs to be able to work. It needs to be interoperable. It needs to have better performance than what we've got now. And we need to have the best security. I'm glad to see that there was a lot of emphasis here this morning on use cases and performance requirements, because we think that that's what it's going to take to actually see that kind of wide-scale deployment. And at the same time, we realize that there's probably a lot of competitive sensitive information as we start to develop that. We're all still, it's great we're all collaborating, but at the same time we're somewhat competitors as well here in this room. Good news is that we are a 501c3 nonprofit. We like to tell ourselves that we are an honest broker in the development, the interoperability, the integration of wireless capability. And so we've done that for a number of you actually that are here this morning or this afternoon. We're focused on real-world testing, whether that's be commercial or private for like the defense market. We understand that space very well. I would share in some of the thoughts that others have given earlier about spectrum sharing. We've got a lot of expertise and capability in spectrum sharing domain. And I do think, we do believe that there is going to be quite a bit of opportunity for Open RAN to be able to address some of the spectrum sharing issues and things that a lot of us are involved in talking about today. At the company, we have a lot of real-world commercial expertise. My senior wireless engineers over there, Anchor Mystery, be glad to talk to you as well as I will. We build test beds. We have test beds. They're just inside the D.C. area. If anybody lives near there, be happy to have you guys come and visit our test bed in D.C. But we'll also build new test beds as well. We also realize that cost efficiency is something that many of you are probably trying to be as we're developing ORAN. We are affiliated with Virginia Tech, which means we get to use all of the resources of Virginia Tech. Several of you mentioned, I think Aloysio mentioned with CCI about the wireless capability that's down in Blacksburg. We're able to leverage that capability down there, and we have done that in the past. And we will also bring students to help us with developing different capabilities and be involved in different projects. So you're helping with workforce development at the same time when you work with us for your testing objectives. I'll just leave you this last thing. It's really a story. There were 3 wise men on an island once who were told that there was a vast tidal wave that was going to come and wipe out their island, and it was going to permanently put it underwater. The first person decided he was going to go to the highest point with his family and spend the last few days in prayer and meditation. The second person decided, I'm going to live up life to the fullest. And the third person decided to hire the best advisors to figure out how to live underwater. ORAN is coming. 6G is coming. We want to be the ones who are the advisors to you guys, who are the third person. That's who we want to be. And we'd love to collaborate with you and help you with all of your different testing objectives. So be happy to talk to you afterwards. Thank you.
All right, Z-Touch Networks. And then folks who have not been able to speak today or not part of the lightning talk so far, get ready. We've got a little bit of time for an ad hoc lightning talk at one of the mics here after the last 2 lightning talks. All right.
Hi, everyone. Thanks for sticking out. I'm luckily not the last one here presenting. And I'm Salvatore D'Oro. I'm a co-founder of Z-Touch Networks. Z-Touch Networks is a spin-off of Northeast University that was founded in 2022. And what we develop is, what we have commercialized is an operating system for cellular networks, specifically for O-RAN networks, that lets you simplify the way you are deploying Open RAN networks end-to-end systems. It takes 10 to 40 seconds to deploy a full end-to-end systems with radios operating over the air to run tests with over the air to verify software and hardware components. So we have an operating system which is kind of like acting the same as the operating system on your laptop. When you use your laptop, you're using a lot of apps, but you don't care about what RAM is using, the system, what are the CPUs, the GPUs, the drivers. You have no knowledge about this. That's our objective, giving customers an operating system where they can operationalize cellular networks that are using O-RAN without all of the complexity that actually takes to deploy that, to monitor that, to control that. What we develop is the operating system as well as SDKs, so kind of like to simplify the way people can develop new applications or can interact with the system, as well as specify tests. And we all kind of like have a catalog of XApps, RApps, and DApps that have been developed for different customers and use cases that is available depending on the requirements of the different customers. But what I want to kind of like focus today is the way this operating system simplifies the testing procedures. So there is a lot of discussion on like testing, interoperability. There are tests that are very well defined. There are procedures you have to follow. And then when the system kind of like pass the test, means that all the procedures are executed, you see the outcome, and then if the test pass, then it means that the system is acting as expected. One thing that it's not captured by this testing is the performance. So one of the things that we notice is that there is a new software release, let's say a new DU component or a new CU component, gets pushed. Then the request, maybe there is like a merge request, then it gets approved, goes into the source code. And then the problem is that you run the test, for example, interoperability or UI attachment, everything passed properly. But the problem is that this is not kind of like giving you a proper description of what are the performance. So what we have developed is a pipeline that not only looks at if the test is passed, but also what are the performance of the system. And what I'm showing here to the top right, this is a pipeline that is fully operational in the last 1.5 years. No one is touching it. It's doing 4 tests a day, looking at, in this case, open interface running on a commercial RUs, looking at the performance and letting you know exactly what are the throughput, the packet error rate. So apart from giving you information about if your test is passed, it also tells you what's the performance. So if, for example, you can use this to identify, for example, in the plot that is below, what are bad configurations of software which still pass the test, but give you very poor performance. You see here, we are kind of like outside of the shaded area, which are the baselines. And instead, lets you also identify what are the new releases of software which are passed correctly, which is the example to the right, which is a good configuration. So I see that Jeremy is up, so I guess my time is running out. And just like if you want to have more information about Z-Touch Networks, I'll be around, so feel free to get in touch. And thanks, everyone.
All right, actually, we have a second to last again. VTEL. We have a slide of VTEL, but I did not. Yes, okay, well, come on up. You got the hot mic. Yeah. Thanks. All right.
Good afternoon, everyone. So my name is Tung Chen. I'm the Deputy R&D Deputy Director of Viettel High Tech. So we have been introduced before from our panelists from Viettel, and also thanks to Qualcomm and DeepSeek also introduced Viettel. But I would like to quickly introduce to you again. We are one of the very few operators in the world that are creating our own 4G and 5G RAN equipment. So like Rakuten, for example, we try by ourselves to create our RAN for our mobile network. But what's different is at the beginning, we created everything by ourselves, not like with many vendors. It's just like a single vendor, Open RAN with single vendor. And the second difference is that we spend a lot of time for field testing and optimization in the real network. Thanks to that, Viettel is the biggest mobile operator in Vietnam. So we had a chance to really test our Open RAN equipment in the real network for more than 2 years. So recently, we successfully developed our massive MIMO G-Node B for the 5G with 32 antenna. So we will be launching 5G in Vietnam in the next few months with our equipment. So it's very successful for our first phase. But we know that to really expand more for our network infrastructure, we need to cooperate with more vendors and more partners in the world. So that's why we're looking forward to everyone here to discuss and find a chance to get opportunity together to really looking forward to like other area, technology area like cloud, like rich, vertical application, and advanced 5G processing, so we can improve more the network. And also we want to join the testing and the lab environment for the ecosystem. That we believe that Open RAN will be really helpful for not ourselves, but contributing in the global telecommunication. Thank you.
All right, last but not least, Tip, thank you for your patience. After this, we'll do an ad hoc open mic for anyone else. So Tip.
Thank you. So to NTIA ITS, I just want to say well done. It's really nice to see everybody have a voice at a conference like this, and to have it all done within the time zone, within the time frame. That's just absolutely amazing. How often do you see that? So my name is David Nowicki, and I work on ecosystem development, and I stand here basically slideless, ready to give you a quick introduction to TIP. So TIP is a US-based, but yet globally focused industry body. There are hundreds of members of TIP, many of you in the room today. In fact, our mission is global acceleration of deployments of open and disaggregated systems. And we do this through fostering collaboration as well as driving innovation. Now, we're at an Open RAN testing conference right now, but it's important to mention that we work with a lot of open and disaggregated systems. We work with Open LAN, Open Wi-Fi, Open Optical, we work with Telco AI, and we also work with neutral hosts. Neutral hosts have been mentioned several times today, and in fact, there's a lot of synergies, especially from an indoor connectivity perspective. In fact, I think I saw an article just last week talking about how the neutral host segment might be the place where there's a lot of big spending in Open RAN, so we all look forward to that. I think that regarding Open RAN itself, we use the TIP process. And if you're not familiar with the TIP process, what that is that we gather requirements from operators. This gets turned into blueprints, gets turned into deployment scenarios and roadmaps, and then the community develops test plans, and that gives us that level of consistency. We focus really on system performance compliance in terms of the area where we want to contribute to the industry itself. This performance and reliability topic has come up several times today, and that's precisely what our group is focused on solving. So we invite you to work with us in that regard. Regarding training for testing and training for Open RAN in general, we have the TIP Academy. The TIP Academy is a platform for training and learning, so that's also a resource for the industry. And I'd like to also mention a very active group within our Open RAN PG, which is the RIA group. The RIA group is a group where we look at taking RIC applications and preparing them for global deployment. Finally, I'd like to invite all of you to our annual conference, which is what we call FUSE. FUSE is our annual event that we bring together all the open and disaggregated technologies. Specifically, the Open RAN group comes together and collaborates. This year's Fuse is going to be held in Dublin, Ireland from November 11th until November 13th. So we invite you to come to Dublin and help to continue the collaboration. Thank you very much.
All right, thank you so much to our lightning talkers. Can we give all of them a round of applause? All right, now, is there anyone who has not had the opportunity to speak today at a session or in the lightning talks and would like to introduce themselves? All right, go ahead and grab, stand up one of the mic up there, or up here, if you, sure. Okay, let's go. All right.
Okay, guys, so I promise I'll be super quick. I'm debating if this is a good idea because I'm sitting between you and drinks. So super quickly, I think everyone in this room shares the same goal, right? Which is to accelerate the adoption of ORAN. And everyone in this room, at least today, I heard it said multiple times, hey, you know, one of the biggest challenges we have is testing, right? And the reality is that today testing, right, for ORAN, you know, there are a few well-known players like Viavi, like eSite. So I just wanted to announce that there is a new kid on the block. My name is Gabriel. I represent a company called Simnovus. So we do it in software. If you want to test an RU, a DU, or emulate a packet core, come find me. Should be pretty easy because I'm tall. Thank you.
Thank you. Thank you. Any last calls? Yes, please come up. Anyone else? Got one more here, but anyone else? Okay.
Good afternoon. Mark Gurnick from Battelle. We have developed a FR1 broadband massive MIMO RU, and we are looking forward to working with the community to work with different DU vendors. So far, we've integrated with 2.8 DU vendors, and we want to be able to continue that development and really maximize the ability of massive MIMO to work in an ORAN environment. Thank you.
All right. Are we ready to depart? To close out today's agenda, since we're all together, policy track and technical track, perhaps for the last time, I want to bring our program manager for the 5G Challenge, for the RIC Forum, and now for IORS up here, Julie Cupp, just to give a couple of thank yous. Julie?
Yeah, so thank you all for hanging with us till the end of the day. It's so nice to see so many friendly faces out in the audience. And I just want to thank everybody for all the work that it takes to put on a conference such as this. First of all, I want to thank Jaysha and her team, Kate, her deputy in command from OIA, to have the ambassador from State Department and the DepSec from Commerce. Wow, that's just incredible. And so thank you for that. Of course, Jeremy for his great MC work as usual, and I love your humor always, the speed dating and all the humor that you have as you go through the ceremony. It's but building on it, so that's really great. So we really enjoyed that. I enjoyed all the keynotes. The panelists, the moderators, the different speakers. I know everybody's been doing a lot of work on the workshops, the interactive workshops and the panels that we're having coming up. So I really appreciate all of that. I want to thank my deputy, Margaret Pinson. She's been amazing as I've been on a lot of international travel. She holds down the fort and has kept everything going. So thank you for that. Larston, the chief technical advisor, I don't know where you are, but thank you wherever you are. He's done an amazing job Oh, back corner. Oh, over there. Hey, Larson, standing. So yeah, he's been great on RIC Forum, 5G Challenge, and now this project as well. And then there's just a whole host of other people. I won't name all your names on both the OIA and the ITS side. And it just takes a village to put these things together. So thank you, and thank all of you for all of your hard work coming here and all the prep that you did. Thank you so much.
All right, last note, actually, next thing on the agenda is a no-host welcome reception. We've received some questions, so I just want to clarify very briefly that you are welcome to join us. It is not our hosted event. They don't know anyone's coming. But if you would like, that's where some of us are headed. It looks like a nice open venue, so please feel free to join us. It is at the Golden Mill, 1012 Ford Street in Golden, Colorado. We plan to be there for a couple hours. So again, it is a no host. We are not providing transportation or hosting or a table. Come as if you want and network and take our party over there. So for those of you joining us virtually, sorry about that. Thank you so much for sticking with us today. We hope you got a lot out of the program. Tomorrow, for those folks in the room here, this plenary main session room will be split in half. We'll do the policy track and the technical track in separate rooms. So I will be emceeing the technical track, and Jay Ray will be leading on the policy track side. So we look forward to seeing you tomorrow. Thank you for today and a packed agenda, and have a great evening.